the last two lectures.
Yeah, that is good. Thanks for that. And then I'm talking even first few minutes I told beyond the lectures as well. There may be so many things happening every day. We don't want to burn our time for that. But relevant for AI, Gen AI, at least top two, three incidents, what comes to your mind in the last 1 week? I'll share my input, but if anything caught your specific attention.
Certainly, last week I had mentioned 400 and some odd data centers being built in
Yes.
the US. Well, there's actually over 2,000 have already been built, and there's over 200 in Canada. They just
Hmm.
announced in our province a $13 billion Meta data center to be
Mm.
built north of Edmonton. So I just wanted to update you on that. I was surprised on the actual number that have already been built.
Mm. Okay, that's interesting. Actually, where it will end, that competition is interesting journey, because yes, we may need these tokens, but my hunch is if there are better learning mechanisms where we don't require these many billions of parameters, definitely those there will be developments on that. Then do we really require those many data centers is my question. But at least whatever is people are building, they are also definitely smart people. So it may be required to meet the requirement for next 10 years, 20 years. We don't know what the plan is. So that is one input from my side. So Rio says what was introduced to the progression from prompt engineering to context engineering to harness engineering to loop engineering. Would you be covering this? If not, can you give me a brief overview? At least I'll be able to cover prompt engineering, context, and harness. It is just we are also doing the agent harness and all as of now. But loop engineering, I'm not very sure. At least I have not used much of that. Other three, at least I'll be able to cover what it really means. But loop engineering, I have not experienced myself. Maybe a new term for a different thing. So you have any idea on that? What is that loop engineering? Or let me try searching what it means. Sometimes new terminology comes with the same uh, practice of building autonomous iterative AI workflows rather than relying on manual single shot prompting. Okay. Mm. Instead of you getting the AI agent turn by turn, okay, that is the loop they are talking. Yeah, yeah. Then in the agent point of it, at least, yeah, I should be able to cover. May not be in the too much of detail though, but we should be able to cover some of those aspects. Next wave. Yeah, it is more of agents, and then anyway, agents also we are talking about. They need to plan, they need to reason. Only confusion among the people is okay when we are defining agents with all autonomous and all. So sometimes we are still stuck with some kind of workflow. It may not be fully agentic. Okay, overall workflow may be static, but maybe there are some portions which are really a dynamic and agentic thing, right? So those things are happening. So what we are going to talk about after covering the agents, I'll talk about something on agent harness, and we can cover this loop thing that time itself. Yeah, it's more on agentic stuff. Cool. Another thing caught my attention in the last 1 week is Apple versus OpenAI. So that we may need to discuss not now though, mostly on the security aspect, privacy aspects, copyright aspects in one of the session. But because it is talking about the lawsuit, it is there in the main media. So the just gist of it, what my understanding is, Apple filed a lawsuit against OpenAI and even its former employees as well. Some confidential trade secret was stolen to advance OpenAI's hardware business. Okay. So the similar thing was there even DeepSeek have done the similar things with this, but they can't file too much of this because that is geographical. I mean, geographical law differences are also there. But this one is both in US, so that's what I see. And uh, another interesting thing is now we are talking about if you are using the Anthropic models, mostly we are using Sonnet 4.5, 4.6 and all. Now the series moved to 5. So another in the similar lines from Anthropic, that Fable 5, Mythos 5, there are some restrictions only for US citizens or like that, right? So they stopped all that. So now I think they are coming back with those things. So any other thoughts from those things? Otherwise, we will slowly go into today's topic.
So two aspects, the graph rag
Mhm.
aspect, this token optimization, that is like, ensuring that the number of tokens spent is reduced, right? Something.
Yes. Yes.
So these two things, if you could touch it a bit.
Yeah, RAG, while doing the RAG, I will try to extend the thought process, okay, how the RAG will work. May not be able to experiment with that, but at least I'll be able to touch that. And second thing is what you were asking.
Graph rag,
Token optimization. The token optimization we will talk on the practical sense because just talking about the prompt engineering only will not be enough. So we'll talk about the context engineering, the combined together context and prompt engineering. We will talk about cache, augmented generation, how we will be able to optimize the tokens, how we will optimize the prompts, some of the design patterns. We'll talk some of them.
sure.
Okay. Yeah. One last comment on that is if you follow some of the news mm, from small companies or even Microsoft level as well, unless you put this Gen AI or agentic AI into the right set of use cases, they are actually it is actually backfiring in terms of the cost. Even Meta also talking about they want to put control on the usage of these tokens. Otherwise, what is happening? The employee usage, there was some number, I didn't remember, 44 billion, trillion, some number. So which is beyond their expectation of these many tokens are being consumed. So they want to make sure they are monitoring those because that is becoming a big cost uh, uh, kind of a chunk when it comes to the development aspects. We need to be mindful on that. So those are the two, three comments from my side, which may be relevant for our topic here. Okay.
Sure.
So then let's slowly go into, unless you have any comments, I'll slowly go into the today's topic. Now, how many? We already, yeah, first 10 minutes we are there. We are already 24 people. So next, tomorrow we have next Saturday sessions and all. I may be delayed by 2, 3 minutes or max 5 minutes. But I have one session to close by 6:30 p.m. my time and then immediately jump here. So just allow me 2, 3 minutes. Even if you join, my recommendation is if you continue the chat in terms of what's first few minutes anyway, I'm going to spend time because it's a Saturday, Sundays will be punctual, no issues on that. In terms of what's happening on top of the AI, which is relevant for you or impacting, just like we talked about 2, 3 things, right? Then anyway, we'll jump in and then we'll add value there. So let me some note takers approved. Let me start sharing my screen.
Professor,
Yeah, yeah.
I have a question about distillation. When DeepSeek were appear, they were told that they distillating the knowledge from all the bigger model like OpenAI and Anthropic.
Yes.
But then what exactly that technical and I mean I have another question. If a good technical, why don't they just keep doing that? Because they are right now again that right. What do you say?
So if I understand your question correctly, DeepSeek, there were allegations that they are using some kind of analogy distillation. How they are doing it is one part, and second part you were asking is why can't they use that technique themselves? These Anthropic and OpenAI. Is my understanding correct? Is that the question you are asking?
Yes, sir.
Yeah. So that's a valid question. So if you see that allegation point of it is very correct, because when they shake the world maybe a year ago, right, or 1.5 year ago, when they first launched it, and then seeing one tenth of the cost, I'm able to get it. Everybody, yes, the market definitely reacted, and then there is 8% shrinkage in the tech shares. But the point is, when they deep dive, yes, they do have some kind of techniques which are not very straightforward. So what does that mean is knowledge distillation is something like a teacher forcing. What does that mean? They are maybe I will talk in some other details with the DeepSeek, but because you are asking, let me tell you. Instead of building from scratch, if you have a reference output from this OpenAI or any of the other model, right, which is powerful, I'm taking. You remember transfer learning? Some techniques from deep learning. Last time also, I think we covered a little bit.
Yes. Yeah.
Right?
Yes.
So in the similar lines, here also something like a teacher forcing is another trick in the knowledge distillation. So what it happens is there is a model which if you want to give it and you are getting some answer, but only thing is there is a reference answer which you are trying to get it as a help, as a hint. Just think like this: when you are given an exam paper and you are trying to write, one is your knowledge you are trying to use and write it. But let's say I'm giving you some hints as a mentor or as a teacher or whatever you can refer it to. That means what? I am giving you some clues so that your search space from the entire search space, I'm trying to reduce it. Okay, you look into this direction, you look into this part, right? So that kind of a teacher hinting, teacher forcing is actually going to improve the performance, especially the latency, especially the searching within the space in a much better way. That's where the knowledge distillation is typically happening, right? So keeping all that, the DeepSeek has able to improve the performance. That is just one technique. I'll talk about separately on the DeepSeek. Beyond the knowledge distillation, there is something like quantizations. There are things which are at least some top 7 to 8 features. What is becoming unique for that we will talk separately. So the similar knowledge distillation, even these models are also people are using, but only thing is they are, but the percentage of that particular value add what they are doing is not that significant when compared to the DeepSeek or other models. So otherwise, people are using their own models, and then whenever there are new model being launched, immediately there will be allegations from this Anthropic and all. People are using massively to query and get some answers so that the people can reverse engineer. So if I have a golden data set which I prepared for every model in the world, I'll just subscribe officially. I'll ask those questions so that I will be smart enough to get those answers and then do a reverse engineering. Those things also people are trying. Instead of natively trying, these are all the different tricks. Are you getting that point? At least at a high level.
Yeah, sure. But I have another I want to just wonder myself that um did DeepSeek trying to get the direction from a mentor from other big model and um beside that, is there any other like technically or architecture that made them outstanding performance than the other?
Yeah.
I read somewhere that they are building like an engine, low level engine using very low level languages to boost the performance, right?
Yes. So there are a lot of, I think your whatever it is coming from your side is just one of maybe some 20, 30 different techniques they are doing, just like knowledge distillation, this and all, right? So even if you see the DeepSeek, their website and then their blog specifically, the good part is they open source most of their papers and their implementations as well, right? So some of these are definitely there, and then some may work in beyond what the DeepSeek is doing themselves. That is also helping the people to build the sovereign models, at least some of the techniques, right? So we won't be able to cover everything in detail in our session, but at least I'll be able to give some clues when we talk about that after a few sections.
Thank you, sir.
Okay. So today the concentration is on LLMs and engineering. And I do have a specific agenda packer for today. Whenever if you are able to complete it fast or complete it slow, so if there is any spillover or if there is anything which we complete, there are enough things to cover for us, because as I mentioned, usually we are short by one a session from compared to the previous blocks where I used to get one extra thing, but we'll squeeze it, no issues. And then wherever it is making sense for you, if it is kind of you are able to get the gist of it, the slides will be there, but I'll skim through. But overall, the point is whatever we are covering, your confidence level should improve and you should be able to practically use it, right? So that's the thing which we will go into. So first few minutes, maybe 20-30 minutes, hopefully we'll be spending time on infrastructure stack, just like we are talking about. So when hundreds of these data centers are being built with the GPUs, the common question for you, being a Gen AI doctoral student, naturally, why do we require that many data centers or that many GPUs, right? Natural question. So on what parameters I can play with that, right? If you are building an LLM, building an SLM. So some of those aspects we will bring into picture here. Then we will talk about the tech layer. Then there are some proprietary models, that means closed source models, open source models. How do you select the right model? At the end, how do you get the better value from Gen AI? I will leave you with some kind of a dev stack as well. If you're able to complete it well, then we will pick up a few more on our way as well. But this is the minimum which we are expecting for today. So let's start with the hardware infra intuition. So at least some of you heard of maybe GPT-5 is there now. That may be the spelling mistake. So it should be GPT, GPT-3 large, then Llama. So now we need to do a small exercise in terms of what are the things given for us? Okay. What are the things we are trying to calculate? So our aim in the next 15-20 minutes is we will take all the parameters what you have here. All this I'll explain to you by taking one example. And then we are trying to get, okay, if I fix one type of a GPU, okay, and maybe a training time or maybe number of GPUs, those are all interchangeable. If I increase this 1 month to 2 months, maybe this will reduce to 5,000 maybe. If I decrease 1 month to 1 week, maybe I need to get some 40,000 maybe, right? So there is an inversely proportional, but ultimately we are trying to give you you can fix this X or Y, doesn't matter. So we are trying to play with this number of GPUs and training time. What is the value add for that? Even if you are trying to build any of such things, when you are estimating your overall training data set, what is the sequence length and all, then you will get a ballpark number. I will give you a simple Excel sheet as well while you are calculating it. So to do that, we do have some more conceptual understanding, which we need to concentrate for next 10 minutes. Then I'll go into the details of it. Once you understand the details of one example, then I'll be able to uh, share even an Excel that we can use it for your own personal purpose as well. Okay. First, to do that, let's understand everybody, maybe as of now, some parameters may be very easy for you to follow. Some I need to clarify. Let's see 1, 2, 3, 4 like this. 1, 2, 3, 4, 5, and 6. Let's say 5 and 6 are the output what you are trying to get. At least 4 are given to us. For a GPT, this is actually GPT, not the GTP. Okay. So if you talk about that GPT-3 large, what is the vocab? By the way, this is from OpenAI. Llama is from Meta, and even we do have Llama 2, Llama 3, all that. Now, what is happening is I want to see what Llama is being trained with, the vocabulary size. Here we do have 50,000 words. Maybe here it is 32,000. So that's the input given. It's not like I'm assuming anything. That's what the models themselves, the model developer have talked about, right? So there are 3 parameters. One, model developer has taken that. Second, it is given, just like, okay, number of seconds in a day. It is given. It is not like, or maybe we have some other parameters. It is not like I am choosing, you are choosing. That is given for us, right? So some parameters will be like that. Once you are able to take these two, Then what is the output? Okay, now these many GPUs for this much of time is required to fulfill your requirement. That means what? Whatever is the total computation calculations, I need to keep it. Then it will be easy for you to go forward naturally. So then we do have a sequence length of fixed 2048. Nowadays, if you go for the GPT 3 or 4 or 5, then Llama 2, Llama 3, that context sequence length may be more. That means this is the what you are trying to push it into a context. Third one is the parameters in the model, largest model trained. What does that mean is the vocabulary size is different from parameters. You can see clearly this is around 65 billion, this is around 175 billion. Whereas tokens in the training set, here it is 300 billion only, here it is 1 trillion. Okay. So what does that mean is the parameters are more like if you recollect from your deep learning mechanism, what are the trainable parameters in the deep learning? Can you tell me? Forget about the GPUs and all, or maybe just your deep learning experience point of it. What are the parameters? Some may be trainable, some may not be trainable. But what are the parameters? Anyone? If you're typing in the chat, let me check it. Is the question clear?
In the sense, top P and
No.
okay. What kind of a parameter?
I'm not talking about that. So in the deep learning, what are all the parameters you have?
In the deep learning layers, neurons per layer.
Exactly.
Yeah.
And then what are the trainable parameters? They are not trainable. Whatever you mentioned. Exactly. The weights and biases, those are the trainable parameters. And the number of neurons or number of layers are non-trainable ones. And there are some hyperparameters, something like learning rate or epochs, batch size, noise, regularization. Those are all the general terminology. Here also, when you say the parameters, what are all the parameters we are taking into consideration when we are talking about the GPT-3 or Llama? These are all transformer-based models. What is transformer and all? We will talk not this week, next week, right? So this week will be very clear in terms of this is what we are talking. Not next week, also a week later maybe, because by the time we want you to get familiar with this prompt engineering and track, so parallelly start with that. Then we will go into a little more depth of it. Okay. So other thing is tokens. By the way, people usually confuse with parameters and tokens. Tokens are nothing but your number of words and tokens. There is a slight relation. Okay, in OpenAI, when we say, especially for English, if it is a different language, the numbers may vary. For English, what they say is around 750 words is equal to 1000 tokens. Okay, it depends on the training data set. Sometimes you may wonder, training data set and the vocabulary size may not be directly proportional. Why do I say that? Maybe the more vocabulary is there, but overall tokens in the training data set is only 300 billion. Whereas less vocabulary size is there, but overall tokens is around 1 trillion, right? So they are not directly proportional. The reason is depends on your data is exactly not the same for both of them to train it, right? So that's where the difference will come. So as of now, you are talking about, take any example of GPT-3. We have vocabulary size of around 50K, then 2000 is the sequence length that is to push it to the context, then parameter is around 175 billion. The same 175 billion, if you talk about GPT-3, 4, 5 and all, it is going to 1 trillion also. The corresponding tokens also will change. In this case, it is 300 billion. So these are given for us. Don't worry about that number of GPUs and all. We need to derive that. Okay, we will take some other parameters from set 2 and then compute it back. Yeah, so there are some questions I can see. 2 hands up. Yeah, please go ahead. Deepak, followed by Bharat.
Professor, just a quick question on vocabulary size. When you say 50,000 in GPT large and 32,000 in Llama, can you just elaborate a little bit of what
in vocabulary is? Vocabulary size is nothing but your let's say the words, what you are talking about. Suppose if you are taking English only, whatever is the dictionary words, and then sometimes it is not just only English, it is having even the coding or some other language. Even Llama 2, they do have other Spanish and other languages as well. So that all increase to the vocabulary size.
So is it in like kind of a single y- context, or is it
Not single context,
like
entire, no, this is all not single context. This is all the training data information I'm talking about. So now where are we right now? In the next 15-20 minutes also, I am talking about this much hardware is required for you to train. Training we are not doing on a day-to-day basis because only few companies in the world are doing as of now. But if that is the case, why are you talking about it? Because that is going to change right now in going forward. Immediately this year, you may not be able to do it because you are having to use the existing models only. But it will help you in two situations. One, your management, your board members or CXOs are asking you, why can't we build a, let's say, a sovereign model for our domain, for our data? You can't, you don't require to say no, but you need to educate them within few minutes by using this Excel, depending on your size of your this and ballpark numbers. Let's say 10,000 vocabulary, sequence size of 2K, parameters maybe let's say 70 billion. Then tokens, let's say we are talking about 100 billion. Just having those numbers roughly from your domain, immediately you will be able to tell them, yeah, give me some 1,000 GPUs for 1 month of this thing, then I'll be able to build at least one training. It's not like complete one, right? So that is one situation where you can use it. And second thing is when you are able to use the available models also. Okay, why these foundational models are really costing this much, or why the foundational models are taking this much of effort to build it? The second situation is to convince yourself, right? So both the situations you can use it.
Thank you, sir. That's helpful.
Okay, yeah. Next question, Badar.
Professor, just about the tokens.
Uh-huh.
Who's defining the number of tokens?
So that is the training data set. Suppose if I have 100 documents. Okay, 100 documents means you may have a Shakespeare documents. I may have my own stories, right? In our local stores, right? So you may have 100 documents. I may have 100 documents. Your vocabulary size may be, let's say, 10,000. My vocabulary size is 10,000. But still, the number of tokens will be different.
Yes.
Correct. So that's exactly what we are talking about. That depends on the training data set which the GPT-3 have used, which is maybe different from Llama.
Yeah. Okay. Great.
Got it? Yeah.
Thank you.
So now in the last 10 minutes or 5 minutes roughly, we are able to tell you the first 4 parameters where you are trying to understand, okay, this is what the sequence length, this is what the vocabulary size, and what is the purpose of each of them. If the number of parameters and tokens are more, that means more computation is there. That is one point. Second thing is if the sequence length also increases, yes, that will have impact on the running time. But as of now, at that time, maybe 2 years ago when they are talking about it, that 2000 sequence length is very good. Right now, you may increase it definitely. Then vocabulary size depends on what is the training data set. It may be 10,000, 20,000, 30,000. Okay. So beyond this, only those 4 parameters are not enough for us to compute directly. Otherwise, I could have finished it within this slide only, right? But we need, because these are all computationally related, you need to go into fundamentals of some of these computational computer architecture, number of flaps, if you heard of, floating point operations per second. Any of you recollect from your maybe earlier knowledge, or it is new term? Flaps. FLOPS, floating point operations per second. Even if you are hearing for the first time, don't worry on that. I'll try to clarify. So it is maybe a little heavy in terms of these calculations. We will do that anyway. First, let me go into this one. Okay. This one I'm talking about floating point. Some of the things which are given here is, let's say we are talking for GPT-3 now, where 175 billion parameters usually requires some kind of 1 terabyte of memory to store the parameters and maybe intermediary states as well. And another thing, it is also needs to store to checkpoint the training state. Otherwise, what will happen? One is, so you can understand when you are trying to do some computation, we in the computer science language we talk about time complexity, space complexity. That means this much is the space I require, this much is the time I require. So similarly here also storage we are talking about 175 billion parameter, around 1 terabyte memory you need. Similarly 1 trillion tokens we are talking about, maybe 300 billion, 1 trillion. So we will do the calculations, but generally 1 trillion tokens may require 4 terabytes of storage. Okay. So some of them depending on the NVIDIA type of the memory as well, right? So whether it is high bandwidth memory, then one GPU memory cannot really fit the entire thing. So you need to act smart as well in that. So those things also come into picture. As of now, in the first 4 lines of our description, I'm just talking about memory requirement. The point is, we may not be able to fit it into one one machine, right? So there we may require multiple things. Then the second one is another given point. Any LLM or an LLM typically requires 6 floating operation per parameter and token. Now, both of them are different. One is parameter, one is token. Can you see the difference between the tokens are nothing but your input training data. Based on the training data, maybe they are words or something else, you are trying to convert it into tokens. That is one parameter, one, let's say, element for us. Another one is a parameter. So parameter is nothing but what your trainable parameter, non-trainable parameters to play with these tokens. They are also in the millions and billions, right? So a combination of the parameter and token actually requires 6 floating point operations to do any of whether the dot product, whether some other operation. So that is also given for us. But what do you mean by floating point operations? Just think of it from your own computer. You may be using your Mac, or you may be using your whatever, Dell, HP, any of this. If I make a statement, you are using either 32-bit operating system or 64-bit operating system. Does it make sense when I make this statement like that? Yes, no?
Sorry, it's a bit fast on the flops. Could you please elaborate it again?
Okay.
Thank you.
So floating, I'm not completed that yet. I'm just still going there, floating point operations only. So I'm trying to connect the dots here. So everybody is using your computer in your own laptop. If I say you are using either a 64-bit machine or a 32-bit machine, does that statement make any sense for you?
The 64-bit machine means it's faster, right?
Yes, 64-bit is faster.
Yeah.
So why do you use it? Maybe while purchasing it, you may worry about it. That's okay. But even after that, when you are installing any software, either in Windows or you go to the Mac, you will have different options, right? Whether you want to choose a 32-bit machine or a 64-bit machine, that installation also will differ. In the chat, somebody says yes, or yeah, it defines the speed of the machine, Nimish says, right? So even if you are getting any doubt on that as well, we can definitely show it to you. Anyway, I'm going to share the full screen now. Let me stop sharing this part of the thing. Because I need to share one Excel sheet also, hardware calculations, whatever we are talking about. Yeah, some data is given to us, some of them we are talking here. So now if I share my entire screen here, yeah, share. Okay, I can share either screen 1 or screen 2. Okay, I'm sharing the screen 1 now. Let me still go to this part. So it may not be full screen, just bear with me for a few minutes because I'm switching the these things. Just to make sure you are with me, if I go to any other okay, here, if I talk about, let's say you are trying to install, let's say MySQL, just as an example, right? Install for Windows or Android, sorry, for Mac. Even if I'm taking here any of them, MySQL downloads, there will be installers. I'm taking just as an example this one, community downloads, installer for Windows. Okay. So can you see here? 32-bit. Yes, no? So here we will be able to select based on your machine whether it's a 32-bit or 64-bit. What does that mean? for you. So again, I go back to the computer basic architecture. So your system, everybody knows integer and floating point, right? Floating point means, let's say 1.002, and all that. So you are using 32-bit to store a floating point in case of 32-bit machine. In case of 64-bit machine, whether it's Windows or any other hardware, doesn't matter. You are having a lengthy. That's why the computation also will be more. Okay. So now it is playing an important role for us while doing the calculations. Here, this is also I am not defining it. Once you understand parameter and token, this is also given for us. Okay, 6 floating point operations typically it takes. Now for GPT-3, how much it takes GPT-3? That depends on, okay, these many parameters are there. GPT-3, 175 billion parameters. And number of tokens, how many? Maybe 300 billion, right? Like that, we'll do the calculation in the Excel, don't worry. But as of now, this is given. And these many operations are required for an LLM, okay? Into, let's say, whatever the 6 floating. But this will give us the overall computation required. But what else we need to do? In a GPU, what is the typical and how many operations it can do? This is what the requirement. Just understand one left side and right side. Left side we are talking about, this is my requirement of LLM. These many parameters, these many tokens, and per token or per parameter, you need 6 floating point operations. So I'm getting some requirement. That requirement needs to be fulfilled by the hardware, underlying hardware. Let's say GPU of NVIDIA I'm taking, and there are also multiple H100s, V100s. There are different varieties. Each of them have their own capabilities. So right now, you don't require to worry about this part because we are still computing that. So let me show it to you here. So number of tokens is 3 billion. Number of parameters is 175 billion. Then number of flaps is 6. I just multiplied these three in terms of E5 into D5 into F5. That will give me these many 10 power 23. These many floating point operations needs to be executed. Are we good so far in terms of the requirement? Before we calculate how many GPUs are required for how much time to get these many operations to be done is the next part. But are we clear with the requirement first? Yes, no?
Sorry.
Yeah, Nimish. Sorry, you have a question, Gwen?
No, oh no, sorry. I kind of get it, but I'm not there yet. Sorry.
So we'll go slowly. Once
Yeah.
we do the calculation, you will be just follow up in terms of what is only people will confuse with what is given for a particular model. What is very standard. So let's say this 6 floating point operations is not depending on LLM. Whether you use GPT-3, whether you use your model, doesn't matter. That is 6 is given for us on an average, right? So like that, you need to understand what is given to you, what you are calculating, and then it is easy for you when you are able to play that. That's where the color coding also will be helpful for you. Okay, we'll get there. So Nimish,
Yeah, Professor, just trying to relate this. So when you try to explain on 32-bit and 64-bit,
yes.
what memory serves it is like, it was something like 2 to the power 32 and 2 to the power 64, right? Is it something related to what we did just now with the multiplication of tokens, parameters, and flops? Is
We are not
this
at there. I am going to
okay?
use that in, let's say, these GPU flaps. So in the 64-bit and all that. So, but they are related only. So as of now, I
Okay.
am able to tell you this is the requirement. To fulfill that, I need to use some hardware, whether it is GPU, CPU, and all that.
Yeah,
There
yeah.
I am talking about whether 32-bit, 64-bit, and all based on the
Okay,
calculation
okay.
differ. Got it?
Okay, got it. Yeah.
Yeah.
Okay, thanks.
So now slowly let's go into this one. Are you clear how you got this? 315 into 10 power 23. That's what I'm trying to show you here. 3.15 into 10 power 23. So everybody in the class should be able to appreciate at least this part 1. How I got this one. They are just multiplying 6 floating point operations. And how many parameters were there in GPT-3 and how many tokens are there? Till that part, are we good?
Yes, Professor. Professor, one help in
Yeah.
the display settings. Can you swap the presenter versus display?
Oh,
What
you
we are
could here where I can share that.
yeah, just go to the top display settings.
Okay, here, right?
Yeah,
Display
swap.
settings and then swap.
Yeah. Okay.
So you are able to see the full
Yeah,
screen,
yeah.
right? Perfect. So then next thing is in terms of if I go to the next part, this is given, and then GPT-3 model took 3 weeks to train. So then I need to fix somewhere in terms of I can't keep both variable, right? In terms of the time and the requirement of the hardware. So let's fix, okay, we need 3 weeks to train. Then I will tell you how many GPUs of what type. What type also varies H100, 300, I mean, whatever the V100. So let's take one model of H100 GPU from NVIDIA. And who will tell me that it has the capability of 67 teraflops? That is also given for us from whom NVIDIA will confirm based on the GPU of particular type, these many teraflops, that too, whether it is a floating point 32 or floating point 64. Try to digest one more time. Based on, if it is a more powerful GPU, from which may be costly, but it can do more teraflops using, let's say, FP32. If I increase FP64, what will happen? These operations will reduce because that will be more computationally heavy. Okay. So now what we are trying to do slowly is I am fixing, okay, maybe 3 weeks of the duration of a particular H100s, which can be capable of doing these many teraflops. That will help me in terms of getting the GPUs required. Okay, let's see that part. So now, how many? Okay, this one, if it is 4 weeks or 3 weeks, we are talking about, right? 3 weeks I fixed. 3 weeks means what? 7 days. Each day 74 hours. Each hour 3600 and 3 weeks. So these many seconds are there. Okay. Now, what is happening here? G5. G5 means the requirement with the E7 requirement, and these many floating point operations I require. Are we good so far? This is the overall requirement. Within that requirement, I try to divide these many weeks. I have these many weeks. Still, I need to do these many floating point operations. Follow one path, and I will repeat for more time if you're not able to follow later. Now, I do have what H100s are having, maybe what they mentioned, 67 teraflops. So 67 these many zeros to have the teraflops. Now I do this one number of GPUs is nothing but this much of requirement divided by H100 will give me some number like this. And that is not the final number yet. That is expecting 100% of efficiency, but we do have a lot of dependency on memory, lot of dependency on the efficiency. If we have maybe 1/3 of the efficiency, then I require around 8,000 GPUs. That's what we are talking about here as well. Just follow this, and then we'll take another example as well, so that we'll get end to end. So then if they are 100% utilized, you are good, around 2000 GPU, but we are not 100% utilized. Then roughly around 30% based on what? Maybe memory issues, because we can't put the entire thing in one place. We need to spread that memory, and there will be network bottlenecks. You may say, oh, 30% is too less. Maybe I'll assume 50% of efficiency. That's also okay. Okay, but it is not like 2000. I will add another GPU, another 100 GPUs. It will solve. No, not really. At least on the present way of architecture. So they are saying around 6,000 GPUs they may take. Okay. And original LLM model was trained on using older version of GPU, which was maybe around 10,000 GPUs. Okay. So this entire statement, maybe the same thing is there in one of the reference as well, which I have taken. That reference also given to you. But now let's go back to Excel based on what you have talked about. And they can play with that. Now, let's say these many tokens, this everybody got it. Now, instead of 3 weeks, I will take, let's say 4 weeks. Just okay, 7 into 24 into 3600 into 4. these many weeks. Now I'm changing it to, instead of E7, I will put D7. So what will happen? This will reduce the number overall because I'm extending the time from 3 weeks to 4 weeks. I'll get some floating point operations. Now I have H100s, which is saying this many 67 teraflop. That is close to 2000. Now efficiency is okay. Now it may be too much to say this. Maybe it is 50% efficiency. Okay, it is not good. Okay, so then we need around 4000 GPUs. So now this Excel I'll give you anyway, but are you ready to play with that in terms of, are there any unknowns so far? Let me take a pass. When you were able to follow so far? Any particular point you are struggling?
Please
Yes,
give us a few
Professor.
seconds with the slide first.
Slide, or which is easy for you? You want to digest the slide or Excel? Okay, have a look at the slide first.
If possible, can you walk through the slide once again, Professor?
Yeah. So I will not go line by line, but I'll give you a gist of it so that it is easy for you to understand. So just divide the entire maybe 10-15 lines, whatever it is there, into 3 parts. What is given to you by the model? That's what the previous slide is. Previous slide means the number of tokens, number of parameters. That if I change the GPT-3 to the lemma, can't you do the same calculations? We can do that to us. That is part 1. Part 2 is number of seconds, whether you fix it 4 weeks, 3 weeks, that doesn't have any dependency on the underlying model, right? That is standard. Similarly, LLM typically takes 6 floating point operations on the present transformer architecture. Tomorrow something else change, that 6 may become 4 or 4 may become 8 also. As of now, from the typical architecture, these many operations they may require. So keeping those, and we need to fix what kind of GPU style, whether it's a H100s or V100s. That will also give whether it's a 67 teraflops or 50 teraflops or 100 teraflops. They will give based on these 2 different parameters. One of them, which is a standard, second them for a particular model. Then we are trying to calculate these many GPUs are required for this much time, keeping this much of efficiency. That's it overall.
Yeah, one line, what I'm trying to understand is the 6 multiplied by 175 billion, I can understand. The 300 billion from where we are getting?
That is token. That's a combination of, it's not only parameter, right? It is just to go back to the thing. It is, we have parameters and tokens, both of them are there.
And that is based upon the usage model, you are saying?
That is based on the usage model, what is there within that. So that is given to us. If you see that, I got it from this table.
Okay, 300 billion. So that is
this one.
Okay, and that is okay. Tokens in the training part. Okay. That is about the training capability. Okay. Vocabulary size, sequence length. Okay, and that is vocabulary size because of the large we have chosen that, right?
Yes.
And
yes.
Parameters is 170 billion, and tokens in the training dataset is this 50 okay, that is an independent parameter, the passage what we have, corpus what we have taken, right? Okay, and number of GPUs available is this much, and the training time is this much. Okay, whereas in the case of Llama, we are talking about a vocabulary size is slightly lower, and the sequence length is same, and the parameter is optimal. And but
tokens are more. That means they have more documents converted to tokens.
Okay, and the number of which means that as the model is a slimmer model, like we are trying to train with a larger data set. Is that the interpretation?
Yes. So it's more like if I apple to apple comparison means I can have same H100s for these and then calculate for those also. But A100s and V100s may have a different teraflops. Accordingly, we can change it as well.
Okay, and this is 2048 of A100, which is a lower end.
Lower end, yes.
V100 is V100 or H100 processor?
H100 is what I have used for the calculation. So you can go for a comparison of that as well. Here, for instance, how do we H100 versus VA100 versus that is actually given. You don't require to add anything there. Which one is that? V100, right?
V100.
So teraflops, if I'm talking about those, it should be able to give me summary itself. So can you see here? Depending on the one is hyper architecture, ampere architecture, volt architecture, whatever it is. So you can see, and I'm taking from one of them based on the CUDA FP32. Okay, it can be 15 teraflops, V100. Then H100, what I've given you is a 67 teraflops. Whereas A100 is around 19.5 teraflops. Accordingly, that will change the number of. As of now, it is more powerful is H100, and then followed by A100, followed by V100. So this is all given to us. So accordingly, suppose if the H100, if I change it to A100, I need still more GPUs because the number of operations are coming down. That's how you need to read it.
Sure. And our intent is to compute the cost of training, right?
Exactly. So I am giving you confidence saying that even if you are able to calculate by yourself, why we are not going for foundational models? Okay, these many, and you just, I am talking from not from a dollar value. I am talking from these many GPUs for this much time you require. Then just Google it or put it into a ChatGPT. It will give you what is the cost required.
And we don't have this iterations and epochs concept here. Where we will be.
It is there. It is just only for one complete training part of it. Then again, that is still not optimal. We need some more time. We need some more time, right? It's not like entire training will be finished within that. At least something on optimal to run the entire show. This much of requirement is there. We still have epochs, all that.
So right now, what we are calculating is for one run, one
complete entire data to push it into the one at least reasonable training cycle is taking this much GPU computation, these many weeks.
And this will be having a batch and
yes, they will go into the batch. Otherwise, the entire memory it cannot push it right at once.
And dividing by the batch, there will be some calculations also becoming.
Yes, number of epochs and iteration, that will be little more lower level equations. But as of now, I'm trying to appreciate your understanding of why someone says I need 10,000 GPUs for let's say a couple of months to train a foundation model. We are trying to justify with this slide.
Fine.
And with your Excel as well.
Yeah, and one kind of a naive question. When we use one GPU, the learning, it happens with that. When multiple GPUs are happening, to coordinate the learning among them, will there be a overhead?
No. That's where the CUDA architecture will take care of it, right? There is something like a CUDA thing where that is more like a distributed structure. So that is their response because I can't push it into one GPU, entire memory all one. It is for compute. Even for memory also, I can't put it into one. So that's where the CUDA kind of an architecture will help them to take internally. That's why I can't assume it is 100% efficient, right? That's where you can see memory, bottlenecks of network. It may not be there in the entire thing at one place only. Keeping that, I am saying around 30%, 40% efficiency. If it is at one place, a big supercomputer, then maybe it can be more efficient as well.
And I have seen the NVIDIA engineers talking about clocking down to 70% or something so that it doesn't exceed the power, otherwise it will melt all those things, right?
Exactly. So that's why all those things come under why I am trying to put 30% only, right? Because we can't, theoretically I can say, okay, 60%, 70% and all, but keeping all the practical scenarios, this is the way we are trying to talk about.
Sure, Professor. Thanks.
Okay, hopefully it's helping other people question as well. Yeah, Vin, go ahead.
Yes, Professor. So it covers most of the questions. However, could we return to the slide again? Oh no, the Excel sheet again.
Yeah. So I'm going to show this Excel sheet.
This one, requirements. How do you come up with the requirement number again? Do we sum up all of the tokens, parameter, and
no? This is all simple multiplication of three things. The requirement is what are the tokens for my GPT-3, and I can do for the same thing for you in terms of let's say some other model. Let's say the model is there. I'm just talking about or Llama. Okay.
Llama.
So in the Llama, what we talked about, there is something like how many tokens are there? If you recollect from here, tokens are around 1 trillion or something, I think.
Yeah.
Tokens are around 1 trillion. Okay.
Yeah.
So 1 trillion means how many zeros? Anybody remember?
12,
Is it
12.
this much? Hopefully. Yeah.
One,
So
right?
million, billion, and trillion.
Yeah.
Right? 1 trillion. And how many parameters? It is not exactly the same.
55.
It is maybe
5.
65. In this 65. This is
Yeah.
common. This is given. 6 flops is common.
Flops.
So now the requirement is if I go down,
Oh, so it times or
it is more.
nothing times up.
So it is, yeah, tokens into parameters into flaps. That's how it
Got
is.
it. And then
That will give the requirement. And then number of seconds I am deciding, okay, I want to run it for 3 weeks, 2 weeks, 4 weeks. I can play with that. This is for 3 weeks in seconds. This is for 4 weeks. That will give me the requirement divided by these many seconds will give me the intermediary steps of how many GPU flaps.
and you divide
And
it.
yeah, and then
Professor, how
if
do
it is
you?
V100, yeah, so go ahead.
Sorry, for the seconds, so for the tokens, because we only have 21 days. So is
Yeah.
that for the parameters or for the tokens?
Yes. So that means we want to complete the training at least one part within that particular thing. That's where I'm taking 3 weeks here. This is week. This is for 4 weeks into 4.
Oh.
Each of the week it is more like 7 into 24 into that 600. So if it is only 1 week, I need to do this will come, and then I need more GPUs because I want to finish it within the 1 week. If I increase it by, okay, I have a 4 weeks window, then you can see I have only 1/4 of it.
Sorry, I understand the time, but so the difference, so it's different for the tokens and the parameters.
Mm-hmm.
And how do you because there are 2 tabs.
No. This is a separate one requirement, and this is just whether you want to keep it here or separate. There is nothing to do with the token. This is separate. That is separate. This is one level of requirement only. Then I'm not calculating only for tokens. Don't get confused with that. So this is one calculation for the requirement where the tokens parameters are there. Here, this is separate calculation. This is I can put a separate calculation here. This is not tokens. These are computations. That's it. General computations.
And then the GPU flop, is
requirement divided by the number of seconds. Requirement divided by how much time I want to give. These many computations I need to do. How much time I have. That will give me this number of flaps and then how many flaps we have.
Yeah, the like the lower part I can understand, but the upper part I'm just a bit confused. So the GPU flux is calculated by you give the requirement, divide for the seconds for token.
Yes.
And not parameters.
No. I think we are getting confused with the tokens and parameters are only for these two. Don't get confused with these lines. I will cut it. So
Okay.
here I can, so the tokens and parameters are only for this calculation of requirement. Then again, this one is not related to tokens or parameters. This is a general calculation. The tokens or parameters are only worried by the time I reach these flaps. I don't care whether it's tokens or parameters, right? It is just computation for me. Because those are internal details to get to the requirement. Once I have the requirement, I don't care whether the tokens are more, parameters are more. That computation point of it is same. Okay. Only till this point you are talking about tokens and parameters. After that, only the requirement speak for us. This is the requirement. How much time you have? What kind of power of GPUs you are using? And tell me based on the efficiency, you will increase it.
Thank you.
Okay. So you do one more calculation yourself for any of the model, then it will be good for you. So that I am giving you confidence when someone asks why foundational models require this much of computation, or even down the line, a year from now, if you want to build an SLM, so how much of compute you require? Okay.
Sorry, Professor, just one last for clarification. What's the difference between GPU flops and the other flops?
The GPU flap, this is what your GPU flaps is my temporary calculation of my requirement. GPU flaps requirement. This is fulfillment. This is the fulfillment. Requirement means this is what I need. These many computations I need to do flaps.
Okay.
To do that, I have a hardware. That hardware is depending on NVIDIA H100 or media. I already showed it to you in who will define this one? I am not defining it. I am actually getting that from this one. If I have floating point 32, 19 point. Okay, V100 is not even 9, I think 15.7 they are saying. I need to get like that only. 15.7157 like this. So this is given. That's what the color I'm telling. This is given. Maybe I can use the same color so that it will be easy for you. Let's say green. So green is given for us. Okay, number of laps is given. Then this is given. This we are computing. The yellow ones are what we are computing from the requirements. And the seconds are also you are taking that input, right? It is not given. It's not like a standard one, but you are taking that inputs. I can have another. These all given like number of tokens, number of seconds. Those things are given for us. Accordingly, I'll get these yellow ones. You can also give in this. Got it? Yeah. I think you two more questions or one more.
Thank
7.
you.
Yeah. Go ahead.
Professor, a few questions. Is it all based on FP32? FP32, the flops?
Yes, these are all based on FP32. Yes.
Okay, good.
Yes.
The
This
next
is
one
on
is
FP32 only I have taken.
yeah, great. The next one is how we come to a standard flops requirement in calculation of requirement. How does 6 come from?
That is given to
Is it
us.
given?
It is given. An LLM is,
Okay.
as I mentioned to you in this particular slide, that is given standard way. And how is it standard forever? At least from the present transformer architecture, it is okay. Tomorrow, let's say next year, some other architecture is coming, that 6 may become 4 or 4 may become 8. Small changes. That is actually standard as of now.
Okay. So this is somehow architecture dependent, but the fluctuation will be small. Will be
Yes.
around 6. Okay.
Yeah.
So the last one is 30B, the 300B. How we can come into this 300B into calculation?
Which one? In this
The
calculation, this one
300.
you're talking?
Yeah,
This
the
one?
300, 300B, yeah.
This is given here, right? For us, that is parameters and tokens. Those are given in the previous slide. For us, that is also based on the type of the model. GPT-3 has 175 billion parameters, 300 billion. This is what given.
Okay,
If you
okay.
change the model, that will change.
So what we are going to train is take it the 300 billion tokens and come to training across
Yes.
175 billion parameters.
Exactly.
Those
both are given.
Train them?
175 billion parameters are given. 300 billion parameters are given for this particular models. Tomorrow you are going to build your own SLM. You are defining I'll have 10 billion parameters, maybe 100 billion tokens. Can you calculate how much is your GPU requirement? Yes, no.
Yes.
We definitely should come into conclusion by using your Excel.
Yes.
Yeah.
That will give you, there are parameters which you can play, but it will give you a rough number. Okay, these many GPUs are required. If you want faster, reduce the training time. That will increase the number of GPUs. Okay.
Understood.
So this,
yeah,
that's good. So now I'm stop sharing here. I'll share the Excel sheet also along with this PowerPoint here. Yeah. So that's what the first 1 hour key takeaway. So that I need your confidence to understand, as I mentioned to you in the beginning, why these foundational models are not built by everyone because of this enormous cost, huge data, and then a lot of legal issues are also there. Why OpenAI, Google are fighting in the along with Apple is a different story. Even with New York Times or so many other cases are there on the copyright issues. So they need to face on the data issues. They need to find the computational issues. That's the reason it's not like everybody's job to build some foundational models, right? We have enough of those foundational models, thousands of foundational models across, but doesn't mean that every company is running behind that. Only thing what we are doing now is sovereign models, the localized models. There may not be like a trillion parameters, but maybe small ones, so maybe 100 billion or 50 billion, depending on that one. There also, these kind of computations should be a cakewalk for you once you take different examples, so that you can tell to your management, if I want to build an SLM, this is the requirement, and just you during that time, whatever is the cost, if you just these many computations I need to do, this much of H100s I need for let's say 1 month for 10,000, it will give the cost, right? So that will be helpful for you. That's the key takeaway for the first 1 hour. Now, when you are good so far, then we are going into the tech layer, especially the foundational model. Yeah, we have one more question. Wen, go ahead.
Yes, sorry, just a quick one. So, first, I'm out of curiosity, where do they get this data that they used to train professor, like from all of their customer or all of the things collected on the internet or Wikipedia or
Yeah,
the
every
books,
data is
right?
not from customers and all that, because mostly this is the data open. They are not curated data. That's the reason they are facing a lot of legal cases as well. Because New York Times argue saying that yes, the data is available in the New York Times doesn't mean that it is available for your training. They are just doing the web scraping, and then all the articles what were there they are training. Their argument is no, you have not taken our explicit permission for that. Entire thing which is available in internet doesn't mean that it is available for you to consume, right? And then train it. Consuming just reading is okay. So those kind of issues are there, and the data is mostly the open, publicly available thing.
Got it. Thank you, Professor. And then for the LLM, so the only later, if we want to quickly calculate, the only numbers that we can care is parameters, tokens,
Yes.
and the number of GPUs and training time.
That's it. Those are the four
Yeah.
things you have to play with, and then get that ballpark number for your maybe number of seconds, and then the efficiency also play, but that is the secondary part.
Thank you. Thank you.
Okay, great. So now if I go into the next level in terms of where are we here? Yeah. So now from a tech layer perspective, we do have fully closed models, something like PLM from Google, or DeepMind has Gopher, or once get it from public API as well, like GPT-4, GPT-5, or this Sonnet from Anthropic, or open source models, Llama, Llama 2, Llama 3, or Mistral, Falcon. So these are all the types of models what we have. So what we need to talk about from a market perspective is whether who is building that, what are the licensing terms for that, is it closed source, open source, is what we are doing at the first step. If you go into the next step, from a LLM ops companies, even they also have some kind of perspectives, especially because they are increasing from their deep learning expertise, and now they are also talking about some model selection, data preparation. The companies like H2O, Databricks, Data Robots, you may have some of these in your maybe partner list, or even cloud hyperscalers, something like Azure, AWS, or GCP. They are also there, right? So some of the wrappers they may also build. Otherwise, it can be a foundational models. Those are the things from the market perspective what you have. I'll give you a different perspective and then try to combine that. Another one is from application companies. So some of them like law or healthcare or coding. Just now, if you see, there is Llama and Code Llama as well. Right? What does that mean? That's also a Llama, but specialized in the coding aspects. Similarly, here also, you will see different verticals, horizontals, and then each of them they have their own challenges. I'll talk about some of those as well. In case of these, I do have challenges for each of the companies. In this particular case, application companies, the customer retention, because they are specific models, the customer retention is important. For instance, GitHub Copilot used to be top in the chart a couple of quarters ago, and then it has tough competition from this Cursor, then even the Claude Code. Now the customer retention is becoming difficult. So yeah, I have seen so many people who are moving away from the GitHub Copilot to the Claude Code. So that's why these kind of companies, very specific ones, they need to worry about the customer retention, what kind of margins they have. Whereas the earlier companies also they have their issues. If you see the risks in the foundational model companies regarding ethical issues, data privacy, copyright issues. That's why I will give an example of even New York Times versus OpenAI or even Google. So these are the three styles what you are talking from a tech layer. And then there are some things on the numbers. Okay, what is that 14%, 65%? I need to justify daily active users with respect to monthly active users ratio. So what is happening is, are we proving the value to the final customer? So where they will be see the success is just like we go to Google for everything. Maybe now with the AI mode, Gemini is integrated. Is it going to be sustained? Or people are inherently moving to the not just on the search kind of a bar, but maybe on an interactive mode with some chat interface, right? That depends in terms of what kind of value people are. They may be subscribed to this, but how often they are coming. So I do have some numbers for that, and then let me cover those things and come back here. Okay. So these are the things I'm talking before those tech stacks. 1 month retention, if you see YouTube, Instagram, or any of these WhatsApp, it is at a level of 60% median. And chat GPTs and all. Okay, initially people just log in, or maybe it may be a free version for a month or so. After that, it is not like it is reaching the regular WhatsApps of the or YouTubes of the world. Another thing here is daily active users with monthly active users. Daily active users means WhatsApp is becoming so engaging, so you may be using it. But the same level of activity is not happening at a AI first companies because our mindset is not completely shifted towards that, right? So if you see really a value, maybe just like WhatsApp you are going, it may be for everything what you require, you may use the ChatGPT only, but that is not happening now yet, right? If you see the really value, then it will come. These are the numbers I was talking about in this line. While the best company apps have DAU of 65, whereas we have GenAI for 14% only. Okay. So what I'm summarizing in the last few minutes here is we do have these tech opportunities for us, and then where it can come from these LLM ops companies or application companies, or even if you see from foundational model companies as well. So these are the different options what we have, and then it should be helpful for us to choose. On what basis you will choose this model is what I'm going to cover yet. I have not covered, but understand the overall space. What are all different options? If I have only 2, 3, it is not much difficult to get to us. But now we have too many options. On what basis you will come to that? We'll get or we will understand some specific tips. Yeah, go ahead. Whoever has questions.
Thank you, sir. So just to kind of decode this stat, because it makes sense from a business perspective for us to understand it. Are you
Yeah.
saying that Gen AI is sitting at 14% because adoption has been low, or because loyalty is low and people are switching models because of the lack of education of not knowing which one to use for what use case?
I'll say still, am I just think of it, you are subscribing it because you are getting some options, where people are talking about it, you feel it's more like FOMO, right? Feeling of missing out. As if, okay, I'm still using Google, maybe somebody need to use GPTs. So chat GPT, for instance, right? But your question is valid from both the points where, yes, I may have Claude, I may move out of chat GPT. So, but even Claude or chat GPT or any of them, is it reaching the levels of these typical users of these WhatsApps or any of those? Not yet. The reason is people shifting. Maybe the Gen Z is much faster, or the younger guys are mostly. Think of it, in the kids at your home, they will go to Google or these GPTs of the world to get some information.
So you're saying that essentially adoption is low.
Exactly.
Got it. Okay.
Okay.
I assume that's a 0 to 1 problem for this industry, right? The industry is still in
True.
its 0 to 1 phase.
Still,
and
exactly. It will take time. That's the reason I'm. So this only thing I'm telling it is, it's not like people sometimes feel that, oh, it is all adapted, and then people are shifting to that. No, not that fast. It is happening, right? It takes time. So that's what we are trying to refer.
And that statistic that you showed is a consumer statistic, enterprise statistic, or
That is a typical consumer only. Not at an enterprise level, we don't have the data because that is internal to them, right? So we don't have that visibility. Yeah.
Thanks.
Okay. So let's cover a few more aspects before we go and take a short break. What we will do here is we are talking about some infrastructure tech stack, market capture point of view. I'll give you different views while we going through the details. So if you see here, we are talking about foundational models on the bottom. I'll take where is this? Yeah, laser pointer, that may be helpful. Yeah. Here I am talking about foundational models that may be of text-based, image-based, this kind of a view you already have in the last session. So you should be able to get some kind of foundational models, whether it is code level, whether it is a generic, whether it is a text level. So we have some of those layers. On top of it, we need to have some kind of inference and compute, whether it is from AWS or Google Cloud or Azure. Then we do have model tuning. Mostly what is happening is whether you are using only prompt engineering or RAG, that is one level, or you are going with the parameter efficient fine-tuning some of these parameters, that's the next level that will come here. On top of it, we do have some kind of vector databases and then data management, what kind of application frameworks like LangChain you will take. Then you do have even web applications like Streamlit. Then comes actually the production monitoring and observability, where some kind of a Langsmith, Langfuse, those kind of things also come into picture. Or maybe we do have a Datadog or Amplitude kind of observability tools. Mostly they are open telemetry tools is what we are talking about there. So this gives you a perspective of this is what the infrastructure view of, because I'll give you overall multiple views of the tech stack. This is more from an infrastructure. Okay, maybe you have foundational layer, then you do have a cloud as a service from AWS, Azure, then comes the tuning if at all you are going for PEFT level. Then comes some tools on the infra where LangChain, ChromaDB, those kind of aspects will come. Then Streamlit. Then comes the production monitoring level. Okay, so this will give you a view in terms of bottom to top actually in a reverse order what we have covered. Then I'll give you market capture for different things as well, just for your consumption. Then finally, this understanding needs to translate for us down the line. This is what the overall tech stack for me in my application. So these are the things which I need to be aligned with. That kind of clarity is required for our stack. So before I go into the market cap, yeah, any questions you have? Win and then Prince, yeah.
Thank you, Professor. So this seems like so I have two questions. First is so this is like like most of the company. What type of or what industry are those companies that use these tech stack every day, Professor?
So this is nothing to do with the specific applications. Mostly this is a generic one, what I am talking about. Specific to any of those, I'll be trying to get into little more details later. But this is more like whatever the logos I'm adding here may not be exhaustive, because you will see little more if I go to the next one, right? As the next slide, the similar way. Not exactly happening here. You see a different view from a consumer or a enterprise level, prosumer level. Within that, few more logos what we have, right? Enterprise level. So this is not at a tech stack level. That is what a tech stack level. This is what a general consumer prosumer level is what I am talking about.
Yeah. So from what I understand, this is more like consumer. This is
Yes.
the other one is enterprise.
Yes.
Got
This is
it.
at enterprise level. Yes.
Got it. And then what is the sorry, what does PaaS mean? Product
Platform.
as a service?
PaaS is a yeah. Platform as a service, not product.
Oh,
Platform as a service.
platform.
Yeah.
Got it.
So typically for a cloud, you keep hearing IaaS, infrastructure as a service, then PaaS, platform as a service. Then at the upper layer, they may talk about as AI as a service, IaaS as well, right? So they are different. Initially, cloud means only for us some kind of infrastructure providing, or maybe some kind of a compute power, right? So here you are talking about multiple services, platform as a service, infrastructure as a service, compute as a service, AI as a service. These are all given by different services.
Yes, infrastructure. So IaaS,
Yes.
and then PaaS, platform, where
Yes.
they use the platform to build something else, and so it's called platform. and then as a AS service as a product. No. Yeah, software as a service.
Yes.
In general. Thank you, Professor.
We do have a next question by Prince.
Thank you, sir. So basically, if I talk about this slide, so in case if I'm having a generic problem in my organization to cater certain business aspects, so in that case, I should have all these things there to move everything from existing workflow to AI. So it means I should have the model, then cloud services, and then model tuning. So is that the slide is depicting, or is it a specific, like I can choose any of those in case if I have something already available? For example, I have the cloud services are already available. So in that case, instead of cloud, I will pick up whatever is needed in an isolation.
Yeah. So these are more like, if you see, these are like compartments, right? So I can choose one, let's say one vector DB. As of now, I don't think you have a vector DB, but you have something on the AWS. So I am not asking you to change that. Within that bracket, you choose whatever the bucket, compute power, you are already a AWS partner. Please go ahead. On top of it, accordingly, you do have a different choices. Sometimes what will happen because you decided something at a lower level, okay, I'm going with AWS, they may have a certain preference to have, okay, one versus the other. So otherwise, you have choice to choose from this overall compartments, one from each of the compartment, as long as it is compatible and efficient to run end to end.
Okay, perfect.
Okay. Yeah, one more question, Suvir.
So what is meant by observability?
Yeah. So observability means it is very common term here, just like guardrails and observability, which is not very common from machine learning and deep learning. But from when it comes to the LLM ops, what we are going to talk, there are terms like evaluation, monitoring, observability. Okay, what it means is you are trying to you understand the logs, right? Logs and traces, there are slight differences there. Log is actually you are asking some log, some action is happening, you are logging it. But traces are little more detailed. We do have something like an open telemetry standard, which people are using many of recent implementations. Earlier also it is there, but not many people followed. But right now we are trying to follow that open telemetry standard, which helps me or anybody to go in more details what's really happening, and even from GenAI and even to the agentic AI. That means we have complete control of what's really happening there in a little more detailed way than simple logs. That's where the observability comes into picture, whether it is a CloudWatch, whether it is some other third-party tool, open telemetry, any of those, what exact actions are taking, and then we should be able to monitor that as well.
So the monitoring is for which layer? It's for the entire infra, or it's for a particular layer on the infra?
That is actually at what level, end to end. I'm talking about observability is not limited to one of them. So that observability, the Datadog or any of those, you may have, let's say, till the compute layer, we may have at a different layer. That means if I'm executing something at an application level, there is a transfer to vector to get an answer, or there is a service which is running on the AWS to fulfill it. Yes, it is trying to get that observability across. It's not specific to one layer.
Got it. Thank you.
Yeah. Another question, Bada?
Yes, Professor. When I look to this chart or this slide, when I'm thinking about the GenA infrastructure, it should contain either one of these 6 parts, right? It should have as an infrastructure, right?
Yes.
If there's something missing, the system will not be completed. This is what I understand, right?
Exactly. But I'm not saying that whatever the logos I have given is exhaust and then complete.
Yeah.
Right? You may get some other new better methods. You can do it. But overall, these are the things which we are using it. And I'm going to. This is just one view. Just like you have a use case. If you are building an architecture, there will be logical view. There will be functional view. This is like a component view, right?
Yeah.
So I will go a little more details into the other views as well down the line. Yes.
Okay. Great. Thank you very much.
Thank you. I think we answered most of your questions. Logically, we can take a short break. Let me summarize what we have done so far before going for the break, right? So we might have covered around 10 slides in the last hour or 1 hour, 1 hour, 20 minutes or so. What we have understood as a key takeaway is if anyone given an LLM, we understand what is that is given in terms of how many tokens, how much is how many parameters. Once you understand those basic calculations, then you should be comfortable keeping other data points, how much time the training might have taken. Similarly, when you are trying to do an SLM kind of a thing, you should be confident and you should be the driving force in your organization as a change agent. Don't underestimate or overestimate. Some people may try to blabber a lot. Okay, I need these many millions of dollars to bring. Then you go to the simple calculation and then prove it. Maybe he may be correct, he or she, or you are trying to give a realistic number. So that should boost up your confidence is the first takeaway. On top of it, we talked about what are all the foundational models, the pillar, what options will be. It's not like only one, two. One maybe from what we have from these big chains, and then some maybe closed source, some maybe open API based. There are multiple choices. So when you have taken that, what are the risks for each of them? What kind of balance you need to have? Those are the things which we are trying to concentrate here. And then towards the end, I was talking about the adoption range of this Gen AI, and then this particular infrastructure stack, how it looks like to uh, stack them together. And finally, we'll be able to, yeah, this is the slide which I have covered as well, where not in the logo by logo, but we do have from a market capture. So there is some kind of a horizontal from a sales perspective, or maybe from a customer support perspective. There are some companies which are doing good. This may change every quarter, every month also for that matter. And then as a consumer, presumer, where are we? Just some logos, what we have mentioned. So once we are coming back from the break, these also we covered. Some more samples I will take in terms of Gen AI tools, and then we will take Devin as a sample, how things are working with them. So those are the main points, and then we'll try to cover the assignment aspect as well towards the end. And then if still we have enough time, then I can bring in one more view of architecture while it is fresh in your mind, right? So this is what we have so far, and then what we are planning for the next whatever the 1 hour or so after the break. Okay, are we good so far? Shall we have a short break and come back?
Yes, please. Okay.
Yes.
Okay, I started the clock. So by the time you come, you see this is a good one, or evaluation also we talk about. Yeah, another 10 slides maybe what we have for the rest of the thing. Yeah, so where are we? I'll just keep the first slide from our, yeah, this is the one I think. So some more samples I'm going to talk about what this Llama 3 and all belongs to, and then what kind of things we are taking while we are deciding to go and use in our real world implementations of enterprise AI. Okay, see you in 10 minutes. Shall we start? Are you there?
Yes.
Yeah. If you're able to digest so far what we have discussed, it is just a logical continuation only for this. And what I am trying to show it to you here is one state of the art open source Gen AI model, not OpenAI. So it's, let's say, MetaLlama 3. So I'll write, as some of you mentioned, uh, installation of Olama that may not be part of your exercise part. If you're able to complete it, I'll try to give you some codes and then run some things in terms of Olama, then install some of these Llama 3s or Quen models. I'll try to demonstrate some codes and then I'll share that for the people who are interested. So that's the reason if anybody wants to try themselves on a local model, which is open source, Llama 3 is one of the standard ones, just like where Mistral and Falcon models, and which is anyway open source and standard decoder only. So as of now, you may not fully appreciate what is that decoder only transformer. At least people might have heard the transformer. I have not double clicked on that. At least in the next 3-4 sessions, we will not talk. But after covering RAG and let's say our prompt engineering, that's what the concentration for next 2 sessions. After that, I'll talk about this transformer in detail, then decoder only models. Those things we will be able to cover. Till that time, you can understand there are encoder decoder architectures in transformer, and typically the GPT is only decoder only model, and we do have BERT kind of models which are encoder only model. We'll double click on those little later. And we have tokenizer with only 128k tokens. Those are the things which are possible, and tokenizer with those many tokens. And sequence of, you remember, 2048, and here it is maybe 8k is the sequence of those many tokens. Using a mask to ensure that self-attention does not cross document boundaries. So this is more like your masked attention, self-attention. These terms may not completely understandable to you. Don't worry on that part, because each and every term like transformer, self-attention, mask attention, all that we will explain in detail after 2-3 sessions. But just understand these are the things typically people talk about when they go into the details. And then maybe pre-trained over how many? 15 trillion tokens. Okay. So where they are collected, mostly publicly available sources. That's what you have, because this is a public model only, open source model. Even in open source also, there are multiple licensing terms. So that we will usually talk during your copyright and those things. But here also I'm just trying to bring it to your perspective, so that open source doesn't mean that everything is open source you can download directly in your enterprise. Do you agree with me? You don't require to pay,
Yeah.
but still you need to be mindful on the licensing things. So typical licensing things are, I can write it here. If I can cover in this one, I'll be able to skim through during the next session. So one is GPL, GNU public license, LGPL, typical licensing terms I'm talking about, MIT, BSD, Berkeley, MIT license and Apache. Okay, so like that, there are different licenses. Out of the edge, the dangerous part is GPL. Why? Because everything is open source only. It is freely available. Some people may not even understand the difference. Okay, but for us being the leaders, it is your duty to understand what it means. In the GPL, even though GPL, LGPL, MIT, BSD, Apache, all of them are open source only. Within that also different licensing terminology or licensing conditions are there. In case of GPL, what they argue is, if you are using any open source, which is of GPL license, you also need to make your thing, what you developed, as open source, which the companies may not be ready. Right. So why that condition is there? Because that's how the open source software grow, right? That's where their understanding is. But LGPL, less LGPL, or MIT, BSD, Apache, these licenses are more or less, we don't read typically the line by line, but more or less we do have typical approval process, not very difficult for these kind of licenses, because the basic thing as a leader, you don't require to go to your legal cell or IP cell to take to that, because general guidelines says GPL you should be very, very careful unless it is, and another point is if a GPL thing is there, you can't bundle that as part of your prerequisites. You need to make that, okay, you make it, I don't want to attach that in a Dockerization and all. So these are the fundamentally two differences in terms of why GPL you need to be careful. And other licenses also just make a, even the simple Python package if you are downloading, you need to understand what license it is. If not, you need to educate your own team members, just have a check before you download any of the simple pip install as well from the Python package. Okay, that is one. So why I'm talking about that? Because we do talk publicly available sources is fine, and then on top of it, we do have these licensing terms to get it into. That's the reason I covered that part. Then compared to Llama 2, the training data seems 7 times larger. That's where 15 trillion tokens are there. Why? Because the data is little more, yeah. So training data is 7 times larger than that used for Llama 2. And that includes sometimes 4 times more code and even some other languages also if you go further. Yeah. So this is the level of detail you need to go for any of them, Llama 2, Llama 3 of that, and understand multiple perspectives, and then you make the final decision. Okay. So let me complete this part and I'll take your question, Vin. So while I'm continuing that portion of it, maybe 7 times more data to train, 5% of data set is even non-English data set. That gives little more generic capability of Llama 3 where it can understand non-English as well. Then another interesting thing is even Llama 2 also used to generate some synthetic data which is fed to the Llama 3. So some of you may ask everything which is in the public, whether it may not be in the right form, that may not be curated. Can we create some synthetic data? Yeah, very much. Then we are trying to do 3 types of parallelization: data parallelization, model parallelization, and pipeline parallelization. Why do we require? Either to load the data, to perform the model, and then overall pipeline to execute. We need parallelization at different levels. Training runs on 2 custom-built 24K GPU clusters. The compute utilization is 400 teraflops per GPU. So, because you are talking about a group of clusters or GPU cluster, overall it may have, I think, 400 teraflops of per GPU is what they are talking about, which is much higher. We have seen already 20 teraflops or 30 teraflops, 60 teraflops is typically what we have seen. But because it's a cluster, it can do a little more. Then a lot of new safety tools, Llama Guard 2, Eval 2, Code Shield, these are the things which we are able to use it. Another one is co-developed by TorchTune. The new PyTorch native library is also for fine-tuning and experimenting LLMs is used. And the last one, the Llama 3 is available in everywhere, like AWS is guiding, or you can download separately with Ollama. There are multiple places you can play with. Okay. So this is the kind of view I want to share it to you. Just as an example for Llama 3, you can go with Falcon, you can go with anything which is suitable. If I take a pause here for any of the further questions, yeah, Vin, go ahead.
Professor, can you explain again the parallelization?
Yeah. So parallelization here is nothing but there are 3 types. One is data level, other one is model level, other one is pipeline level. First, data level parallelization means you remember the data what you have for Llama 2 or Llama 3. I may not be able to fit it into it. It may require 1 terabyte of memory. That kind of information we have seen earlier, right? When you talk about that, I can't generally put it into one place only. I need to parallelize it in terms of accessibility. That is first data point, because I won't be able to push it into one memory only. Second one is model parallelization. What do you mean by model parallelization? Is the teraflops what you are trying to do, the training operations is not going to run at one GPU. The GPU cluster is going to take. So how do you do the parallelization of the model? Then the third one is a pipeline. So you understand the CUDA architecture, CUDA CUDA architecture from NVIDIA. You heard of it?
Yes.
So those are the things in terms of the parallelization, what they are talking from CUDA programming. What does that mean is CUDA is Compute Unified Device Architecture, especially from NVIDIA, where it is always good to have this kind of parallel computing platform and API that allows the software developer to use the GPU for general purpose processing aspects. So those are the three difference. One is related to the data. How do you store it and parallelize it? How do you execute the model? And overall, how the pipeline overall is built.
Thank you. And for Llama models are everywhere. Does it mean that all of those companies are using it?
No, it is, suppose if I'm tie up with AWS, I can still access Llama 3 from there. If I'm using my own LangChain, I can download it from. So these are different endpoints where Llama 3 is available as a service or as an installation, which you can do, because some people will go for Azure, some people will have IBM Watson, we may have something AWS or Databricks. So there are multiple places this kind of open source models are available. It's not like always you need to download locally and then do it. No, other places also they have availability.
Oh, so it means that it can integrate in everything.
Yeah, it is already part of it. So that means just take example of today's session, what you were talking about LLMs and engineering aspects, right? That LLMs means that foundational models are there. Maybe they have some specific preference based on that type. For instance, all the three what I talk about, Azure, AWS, and GCP, the top players in the cloud. Azure has a tie-up with OpenAI, so first preference will be going with that. Anthropic has a straightforward relationship with AWS, so AWS will always try to promote something from Claude. And then GCP naturally, it will go for their own Gemini or other models, right? What does that mean? Even though they have their own preference, initially, for instance, AWS does not support OpenAI till last year, or even till last year. I remember only towards the last year end, they are trying to give that as a service because the customers keep on asking, you are giving good models for Anthropic, perfectly fine. But still, if a third party point, if I need to try something, like because they have Qwen models, DeepSeek, multiple models, even they do have access to OpenAI right now when we speak. Does it answer your point?
Yes, I understand, but still not quite get it. Why is it everywhere? So it's like integrate underneath everything, or maybe
Yes.
like can easily integrate it. That's what it simply we can put that way, right?
Yeah. So it is offered by these many people means this is very generic. So what I'm trying to say there is, you are choosing Llama 3, you have in your enterprise setup, you may be hooked up with Databricks or AWS or Google Cloud, any of them, but still you have access to this. That's what I'm talking about.
And Professor, sometimes I'm got a bit not confused, but curious. Like for those that open source, like if what is the limitation for open source compared to closed source? I would guess that it's supposed to be smaller size because it has to be downloaded into your computer, and then since it's like open source, but actually like you can't really update it from outside. You use within your company. It means that it will have like limited words or tokens or parameter, whatever, but like along the way, right? It can only be trained using your internal data and not outsource data. And even when the bigger mother company updates something, it might not be updated if you use it locally, right?
True. Your points are valid in terms of what you are talking about. Only thing is, when you are going, even open source models mostly will download locally and do it, but doesn't mean that they are the only place. That's what the last statement it is confirming to you. Even in the cloud environment, also you have access to these open source models. Okay, so usually the people get confused. Open source model means I need to download locally, but that is definitely there because you can't download something on the GPT-3 or GPT-4 or GPT-5. Only thing what you can download is available Llama 2, Llama 3 kind of models. Do you agree with me?
Only thing that what you can download is available. Lemma Fruit Kite.
Come again? Voice is not
Oh,
clear.
sorry. I'm just repeating you. It's a bit fast. So I just understand simply that it's because it's open source, but it can be on cloud as well.
Yeah.
And
So don't get confused that open source means only it is open source and you need to download locally and then do it. That is just one option. Okay. But it is available, just like I mentioned in the last bullet point, it is available even with the standard platforms like Azure, AWS, or any other platforms as well.
got it.
Okay.
And it's not necessarily smaller than the other version.
Smaller than what version?
Like the closed version or like
No, it
because
depends. It depends. Even the closed version also, they do have bigger models like 1 trillion parameters and all. Usually, we may not get into open source because they have too much of effort for the 1 trillion, 2 trillion and all. But there are models, even like DeepSeek and all, slowly they are going into that level of even 1 trillion as well. Right. So, but they are independent. Even sometimes, even you have a closed models which are only 50 billion, but that may be very specific to a particular domain or a task. So very much possible. Those are independent in terms of how many parameters you have versus the open source or closed source.
And is it true that it's cheaper than the closed source? Because you don't need to pay, right?
Definitely. Yeah. Definitely that is there. Yeah. Who have any other questions? Sam, you have a question?
Yes, Llama 3 was released on April 24, 2024.
Which one?
And then Llama 3.
Llama 3, okay.
Then Llama 3.1 was around July 2024.
Yes.
And then Llama 3.2, September 2024.
Yeah.
Llama 3.3, December 2024. And the latest Llama 4, April 2025. So what happens to those old releases of Llama 3, 3.1, 3.2, 3.3?
They will be there. It's more like even we are using Llama 3 as of now as well. Llama 2, I don't know if people are using it. That's okay. But the only thing is whether you are updating immediately every quarter that model, is it really worth of it? That's we need to do practically because in this case, I'm not at in the production level, right? So even in the production level as well, what happens, you are just giving a comparison of Llama 3, 3.1, 3.4 and all. Even in the closed source, the SONET 4.5, 4.6, now SONET 5. That also kind of upgradation only. So what it typically happens is the moment they say we are updating the model, it's not like tomorrow I'm going and jumping an enterprise AI and then pushing everything to that. No. It takes a couple of months of effort typically to finally migrate one version to another. For what reason? Depending on how complex production system you have, you need to analyze, run all the prompts with the new environment and make sure it is not breaking anywhere and the overall performance is at least as good as the old one. Then only you will get the permission to upgrade it. That is one point. Second point is no, I'm not happy with the new performance. I'll stick to this one. Okay, temporarily it is fine. But after some time, what will happen? AWS may say that this is end of life for, let's say, Llama 3. I'm just giving as an example. Then what will happen? I'm not going to do any of your support. As long as you are trying to use your problem is solving, I don't mind. You keep using it. But you don't ask me that you need update, I need issue this one. So in both the cases, what I'm talking there is, yes, we need to update based on the requirements. And then second point is, we need to make sure the right version is available. And then if it is fulfilling our requirements, then only we'll upgrade. Otherwise, we will just close it.
So from your past experience in your development operations, have your team been keeping up with and jumping ahead with those releases, or you skip one or two?
Some of them I'm skipping in between as well.
Right.
Then as I mentioned to you, exactly that's from a practical experience only. It's not there in the slide as well. When we get a new version, we keep getting a couple of months of time. You may get 2 months, 3 months and all to migrate. The migration process also earlier it used to take time for us, but now we are able to do some kind of automation, regression testing, because the performance from a customer point of view, they don't care whether I'm using particular version or a new upgraded version, right? He will crib or she will crib if it is the performance is down. It is my duty to do end-to-end testing. Okay, so that's the activity we are doing, and only sometimes we are forcibly. I'm happy with the overall service, but sometimes it is end of life. I need to forcefully migrate to the next one.
From your experience, do you see using closed source they are more helpful if you ask for specifications and upgrades?
Depends on, because you have both the I will talk about that in the next slide in terms of when to choose what, right? That time it will come. It's not like I have a complete positive opinion towards the closed source, right? We will talk on that.
Thank you.
Okay. So if you're able to address these questions so far, then let me slowly jump to the next topic here. So the questions we are answering, hopefully for others also you are getting insights, right? So that's the reason I'm just, whatever is the relevant question, I'm trying to take it and then try to wind up. So another interesting thing is what kind of, so there are some benchmarks. So suppose you come up with your own LLM, okay? So when we talk about it, you want to mention it is beating a benchmark. You keep hearing, okay, DeepSeek beat the benchmarks of so and so, or maybe some model is able to perform 90% of the world's toughest exam. It is passing with this so and so. So when we talk about such methods, what happens is we need to understand what is the typical benchmark, right? Evaluation benchmarks, whether it is MMLU, that is massive multitask language understanding, or the language understanding, then GLUE, general language understanding evaluation. So these kind of things comes very handy. And then we do have the reference URL for each of them. What we need to think through here is what kind of benchmarks you are trying to do based on the application. Some places you are trying to talk about Q&A, some places you are talking about understanding the evaluation purpose for a standard NLP tasks. Okay, so these kind of things which we will have as handy. Okay, that's a reference only I'm talking about. So if you go further on that in terms of where are we? Yeah. So I will show some of these benchmarks by taking the same Llama 3. Why I have given that slide there? Because we are busy with our things and then realize there is a Llama 3. This is where we are trying to see the benchmarks of it. Why do we use Llama 3? Somewhere you need to get confidence it is doing good job, or maybe Llama 4 for that matter, or 3.1, 3.4 and all. So what we are trying to really do there is we are trying to create a golden data set, high quality human evaluation set. How many? Maybe around 1800 prompts that cover 12 key use cases. That is very important for us, even for you. When you are really trying to test it, we always recommend to have some kind of golden data set. Why? That will be helpful even for the new upgradations and those things as well. Okay. So, such as asking for advice, brainstorming, classification, closed question answering, these are the different examples people are talking about, coding, creative writing, and all that. So, to prevent accidental overfitting, even the modeling team does not have access to the evaluation set. Okay, that is very common. So when we talk about these preference rankings by human annotator based on this evaluation set, what does that mean is we are trying to evaluate this model against some kind of performance. Then you need to be clear what are those. You need to compare apple to apple, right? So on what parameters it is doing good, what parameters it may not be able to do good job. That can be a good summary as well, right? That also we will cover. So if you go further on that in terms of yeah, I'll take a pause, after covering this part and for any of your comments and questions. So the same Llama 3 in the last 2-3 slides, this is the level of details you need to go with. Okay. So now same MMLU, GPA or human evaluation or math. So these are all the different parameters we are comparing against. And then you have Mistral data, 7B, 8B, all that is 7 billion parameter, 70 billion parameters. That is the kind of example what we are talking from left and right. So you can clearly see in terms of 8 billion parameters, so we do have parameters which are at a 68 or 70s level, where the 70 billion, the same things are going at a 90s level as well, 80s, 90s. Okay. So depending on the complexity of the data, we can see which method, whether 7, 8 billion, 2 billion, 3 billion, these are all the small models for small tasks. But if you want to use the bigger models, then definitely the computation will be more, but the performance is also definitely better. Similarly, if you see the last one here, in human evaluation, specifically for Meta Llama 3 versus the Claude Sonnet or versus GPT-3, because I'm trying to compare 70 billion parameter of the Meta Llama 3 with standard Meta Llama 2 or maybe GPT or even Mistral. So how they are performing in terms of the win rate. So here, what is the summary? How do you read that? Is compared to Sonnet, we do have almost like 53% of the time they are into the this activity. Okay. So similarly, there is a tie and then loss as well. That also will depend on how much we will be able to close it with. So in summary, for all these around 1, 2, 3, 4, 5, 6 slides, what we are talking about. Okay. So maybe I can take a pause at this level. Any of them is also okay before introducing 10. Okay. So that's what it is. So in nutshell, if you're taking if you're taking Mistral or any of the model, you need to understand the high level view and then trying to get it into a situation where it may not be best in all the scenarios, but still you will be able to get it into a good understanding on how we'll be able to use it, what are all the parameters you need to consider. Those are the things which we'll be able to continue further discussion. Okay. I'll take a pause and then shift the gears to how do you choose the model. Any questions before that? Yeah, Vin.
Yes, sorry, Professor, can you quickly explain very simply what the abbreviation here means?
Abbreviations here, it will go back here. So this is the one. So glue benchmark or MMLU means massive multitask language understanding. This is what exactly coming from here only.
Yeah, thank you. So they benchmark one of the evaluation.
Yeah, these are the benchmarks. Yes.
And this is the score. Thank you.
This is the score. Yes. Another caveat I can tell you is any model may not be able to beat all the benchmarks, but whatever it is beating even one benchmark, they will be able to say and publish, yes, I'm able to beat the state of the art with lower parameters or whatever the advantage you want to tell that is also possible. Yeah, there are a few more questions. Go ahead.
So, sir, these are the benchmark. Actually, what are the parameters that these benchmarks utilize to come to this number? So, for example, in case if I'm utilizing an AI model, writing a very complex code, right? And in that case, are they these benchmarks taking certain parameters from that area, or as you just covered one example where they are solving some of the toughest exams and coming up with the correct results, maybe 90% or 95% in that. So how exactly they are, evaluating these parameters and then coming back to this number?
Yeah, usually the numbers of the benchmarks, any of them, right? They will have a golden data set which you need to evaluate against that, whether it is a tough paper, whether it is a coding, depending on let's say you come up with your own model, right? You can also challenge them saying that, okay, this is my model. I want to test it at these things based on whatever your training is. If they are able to run well for the golden data set and then able to beat the performance, then that is a benchmark for you, what you are talking about. So To answer your question, any of them, let's say MMLU, that massive multitask language understanding. So that means what some kind of language understanding is coming into picture. Then another benchmark can be some kind of evaluation. We do have what is that? Another translation. For the translation, you do have different benchmarks. So there are some reference data sets which will help you to challenge the benchmarks even with your implementation. So if it is meeting that, then on the top list, they will be able to help you out further. Does it answer your point?
Yes, definitely, sir. Thank
Okay.
you.
Go ahead, Simon.
So, Professor, so recording number generations evolve very fast, right? In several months, a new release comes up. So that brings me a perception on the revenue side that is every model, if every LM model bring revenue to the company, or still nowadays, nearly every model is losing money or something.
Yes.
So
Yes.
I'm guessing any benchmark in terms of ROI can measure the company
So
performance.
that's a good interesting point, but ROI measurement requires a lot of other things to understand as well, in terms of what technique you are trying to use, how do you really do the optimization. So those are all also linked, right? So what we will typically do is let's understand the building blocks, and then in one of the session we'll be able to cover what are all the things which you are trying to do to have this ROI calculations.
Yeah, thank you. Looking forward into it. Yeah,
Yeah.
thank you.
Yeah, one more question, Badar.
Yes, Professor, about the numbers or the scores in the benchmark. Are they fixed values or
No, they are not fixed values. This is what the running of that is coming, and then the claim from Meta. So they these are not the only 4 or 5 evaluation metrics. You may have few more as well. So, and a simple analogy I can give it to you is if you recollect any of the ad from cars, for instance, they will highlight where they are good at compared to the competitors, and they will not list, let's say, 50 different parameters what they can compare with. They will highlight only 5 which is good for them. Right?
Okay.
So they're like this. There are few more parameters. It may look like, oh, the Llama 3 is beating these Mistral and other things as well. Need not be. Even Claude also, we are saying it is beating, not at the all the places. But at least they will highlight only those metrics which are there here.
Okay. And where we can find these numbers? Is it in the references that you give to us also?
Yes, we do have. I do have the references, and then this is public information only.
Oh, thank you very much.
Okay. So
Thank
if
you.
I continue further on that, thank you. So what is happening now in the last few slides, what we have, then we will go to the assignment as well. So I do have maybe 3-4 slides to come to before the references. Yeah. So let's cover that and then take any of your further questions. Then I'll spend some time on the assignments. I don't think it is published yet to you, right? Assignments. I'll ask them to publish today/tomorrow if it is not already done.
Still not appearing for me.
It's done yet. Yeah. Because I have not confirmed them, so I want to talk to people. Then I will be confirming to them. Where are we? Yeah. So in case of this Devin, any of you it or used it as a first software engineer in the world? Am I seeing any responses so far? Not yet.
This is the login which has been given a couple of days back.
In your organization or through your GGU you are playing?
Through GGU.
Oh, is it? Okay, very good.
No, I need to confirm because the name, I remember something Yes. Okay.
But Devin, I don't know whether they may have given you some Azure related
Yes.
access
Yes.
through third party. May not be Devin.
Yes. It was
Or
a Neo Pro.
NeoPro, not the Devin.
I think Devin is a coding platform, right? Which
Yeah, it is like not just only coding. Typical software engineer, what are the tasks they will do? As I mentioned to you in this right side, this is where, and then mostly as it is maybe now we are talking about Cloud Codes on the cloud and all that. It is one of the first AI software engineer which is doing some of these activities, right? Like autonomous coding, definitely. Now we have a lot of options. Even this also doing learning new technologies, quickly learns and effectively applies these new technologies as well. That's good for us. Then building and deploying apps, so capable of end-to-end application development, and then incremental feature additions. Then bug fixing, that is important. Understanding the new code and then writing it is fine, but going into the bug fixes, understanding the old kind of system is also very much possible. Then model training can train and fine tune AI models, including setting up the fine tuning of these LLMs. Then contributing to the repositories. So it can be contributing to the documentation, addresses bugs, and then contributes to open source repositories as well. And then mini robot brain training is what they are capable of. Okay. These mini robot brains to perform the specific tasks within the project. So while you are doing it, what is the performance of it, right? So, and then I'm not saying Devin, this is the only one, right? Now you are trying to have agents even while we speak, there are activities which we are trying to do from the Devin, or it can be Devin or any other cloud or anyone, doesn't matter. So what are the activities which we are trying to do? And then how we will be able to choose one versus the other. So that's the last part, right? So if you see some benchmark, just like software engineering benchmark, there is a benchmark which will tell if you give these activities, Devin, maybe around 13% is what they are talking about compared to any of the cloud or this. But this is the world comparison. That means what older version. So how it will work in the present scheme of things. It is a challenging benchmark that asks agents to resolve real-world GitHub issues found in the open source project like Danjo or scikit-learn. So that will be a good exercise for them to really see whether they are in the need for the human engineers, or do we take the help of these kind of agents to take the help. Are you getting it? One, you are trying to benchmark and show it to you, saying that yes, this is performing well for these things. And then in practice, it may depend on whether you are getting exactly the same in terms of the benchmarked one or some other comparison which you need to do that. So that's the thing which we are talking about. So overall, it is at least close to 10% better than other ones. But if you compare with Claude 3, Claude 4, I will not be able to see much of the difference. But as of now, I'm trying to uh, highlight, yes, Divin is capable of these things, and it is going to the next level as well. Okay. And people are using it. It's more like, okay, I'm able to replace 5 people with 2 agents we can call, or maybe the Devins, right? Because they are third party ones. If you are developing your own, it may be your own. Okay. If you are talking at that level, what is really happening is we are talking about some of these benchmarks. You understand how to read those benchmarks now. Then we are trying to see the performance because it is doing good job in at least one of or two of them. It is good for us to see what is happening and then take it forward from there.
Is this a Infosys proprietary tool?
Nothing. It's a public one. So Infosys also may be using it. There's nothing to do with the Infosys thing.
Oh.
This is a public thing. They will charge for, just like you are talking about the person or maybe the resource. So they will also talk for that level.
Professor, I see nowadays the latest model
Mhm.
or it reached to over maybe 70% resolved.
Mm.
Is it more advanced than this scale
Maybe it is,
nowadays?
but whether that is SMUE benchmark only or some other benchmark, you are talking about exactly
The
the
same
software.
one, SWD,
Maybe it is. This is one I
benchmark.
am giving. Maybe I should have told you this is a when they released it, right? This is maybe an year old easily, right? So now I'm sure they might have improved. The newer versions of this Devin also might have improved. It may not be stick at that level. Even when they are trying to give it, I'm telling there is a clear difference of Devin versus other models is what I'm trying to demonstrate. Now, I'm not saying this is the state of the art. We do have others.
Understood. Thank you.
So the last part of it, how do I connect these LLMs to the rest of the world? And before that, let me tell you on what basis you are going to choose. Some of the metrics what you are trying to choose these methods, right? One is definitely the cost. I'm writing some of these points here. I want to make it interactively write that so that you will be remembering that based on what we have discussed in the last 2-3 hours. So one is definitely the cost, then whether they are open versus closed source, that is one close. Then the performance of the model definitely, and popularity of the model. So that's where the benchmarks are come into picture. Popularity of the model, performance of the model, and is there any model specific or generic? Model specific versus generic. Okay, so if there are any other points come to our discussion, I'll try to write that. But otherwise, if you see, when we are dividing these specific points, one is, okay, where is the closed source? How are you charging that? What kind of model? But another one also, if you see model specific or generic, or even there are something like reasoning models as well. So explicitly, unless you ask, there is no point, right?
How about speed?
Yeah, speed also that's where the open I think performance is speed is the latency we're talking about. Have I used that somewhere? Latency is also matters. Instead of speed, I'll call it as latency. Okay. So that depends on either it is how do you call that? Offline or online. So that may be one division. Okay. So any other points I missed out? Some of them are self-explanatory. If you need me to double click anything you mentioned. So otherwise, based on the cost, based on the open source versus closed source, based on the performance of the particular model, based on the benchmark, how much is the popularity of what is the popularity of this? Then a specific model do we have or a generic model I need to have, or maybe I may need to do something on the uh, reasoning models. Okay. Then the last one is sorry.
Accuracy, where would accuracy
Yeah,
fit in?
performance. Performance is all that.
Right.
Yeah, third one means the accuracy is one part, but other benchmarks is I covered in third. Yeah.
Thank you.
Okay. So while you are digesting that, if you have any other points like this, I may say it is part of it. I can add one also, but primarily we are able to cover this, and then we keep correcting these, right? And then that's where we are heading towards. If you see this kind of Google has one one ambition, I'll say. They're trying to have infinite context. So, but it increased a lot, 1 million for the professional version. Initially, we struggled to get even a 200, 300. Okay, now we are talking about having almost 1 million, and even in down the line it may be. One advantage of, so, or just think of it, what is the advantage of increasing this context size?
Maybe a larger document summarization or
Exactly.
understanding a legal dispute.
Very
So
good.
what is plotted on the y-axis?
I'll show it to you the same thing, the number of the context size only.
Okay.
So if you see GPT-3 has 2K, you remember GPT-3 in the beginning we have the sequence length, right? And then slowly we are increasing 100K, 1 million, all that. We just shown plotted into the timeline, that's it. So some of the examples, just like you are talking about, with will it increase the cost? Naturally, it will. We need to be optimal, definitely on that. But it gives a perspective for us, saying, okay, when you are trying to do a migration kind of activities, when you are trying to do the large code base kind of analysis or refactor, so definitely those things are useful in having a little more cost. Okay, on what we are doing so far. Okay, so that's what this one, and that brings to the last topic, and then we will go to. So I do have before references one simple dev stack which may be useful for you. But before going there, how do I get the better value from GenAI, right? So some of the terminology maybe you are able to appreciate as we speak now. Other ones we will be able to understand down the line. So when you are talking about a development, that means you have a great idea in your mind. You are referring that infrastructure stack and all that. Then what happens there is, okay, let me tell you in terms of the model development stack. Okay, yeah. What we are trying to do here is I have given you an infrastructure stack, but I want to leave you with, okay, if you want to have a simple model in your mind, how do we create a dev stack as a key takeaway from the second part of the discussion? So what we will do here is we may have emerging reasoning technique like chain of thought or train of thought, all that. Then transfer learning things we can use from RLHF for fine tuning or parameter efficient fine tuning. You can use some RAG kind of methods. So I'm going to continue in the next two sessions, prompt engineering and RAG, which are basic for this. Then new developer tools, we may have something like Langsmith or LLMFs, the related one, right? So weights and biases is another company. Then AI first infrastructure companies also replicate or anything on the model, or unbundling the public clouds and providing what AI companies need most. What does that mean? Plentiful GPUs at a reasonable cost they are trying to give. You choose whatever you want. I don't want to come in the picture. But that gives us an opportunity in terms of how we want to make that model more efficient. As of now, we will go at one level, but we will need to continue further in terms of how do we make that into a reasonable structure. Right, that's the key takeaway from today's one, and I'll be able to double click further once we go into the other sessions. So this will be the last slide from my side before I answer your questions and then go into the details of assignment. So I might have confused you with a lot of components and all. Now I'm giving you a cleaner structure. So you don't exactly require to follow these. That kind of flexibility is there. But at the same time, what is really happening there is you do have infrastructure layer, either AWS, Azure, or GCP. That's what you have seen here. Yeah. Then storage layer, you can have one example I'm saying. This is not the best one alone. Single store. Then model layer can be OpenAI. Then service layer can be LangChain. And then UI layer can be the React. Okay, so this gives you a confidence that these are the things people are really talking about when it comes to the Gen AI dev stack. If I take a pause, any specific questions?
But the, looking at this tech stack, it looked like quite expensive because a small scale companies, I don't think they
Definitely.
could even
So,
afford it.
where you see it is not affordable point of view, it's not like
No,
impossible.
so
Hmm.
small scale. I'm not talking about a very big tech companies. For
Uh,
example, if someone starting a small
yeah,
company, big
yeah, yeah,
startup.
yeah. So what is the tech stack? That's I'm not recommending. This is for my enterprise AI where the people have some of these tie-ups with any of the GCPs, the basic assumption when I built it. But when you're talking about the single or maybe a startup, what kind of tech stack and all, we do have in the upcoming sessions a different view of the architectures. But just for your information as well, we do have, let's say, LangChain, LangGraph, LangSmith, LangFuse at a different layers, what we are trying to bring on the table, right? So that I agree. It's not like, I'm not saying this is the universal one. This is like one example for a typical mm, uh, enterprise setup. Let me leave you at that level.
Professor, so
Yeah.
how do we have like in reality, how do they connect? Do they do connect via API, like the
Uh,
whole system,
yeah.
right?
So they do have a connectors endpoints for each of them. So each of them will have this is the output from either layer. This is what the consumption. Whether you have a JSON as a format, how are you trying to push that specific format? Those kind of agreements is what they have.
Yes, and um, sorry, I was about to ask something.
Mm-hmm.
Um, uh, oh, sorry, so I suddenly forgot. But for these, sorry, I remember in that second. Suddenly I forgot.
No problem. You just recollect whenever you have, you can ask. So any other questions? Okay, I don't know why the video is off. Okay.
Yeah, Prof, thanks for this simplified stack. Actually, it helps us contextualize how we can implement in our own organizations. Obviously, a lot of innovation on that service chain layer, depending on what organization and what kind of use case we have. My question is actually linked more to the detailed slides that you had, the generative AI market map, two slides that you had. And
Yes.
the first one being largely the infra, and the second one being more I guess, the application, consumer, prosumer, however it's kind of bucketed. I want to link this back to your last weekend's class where you had shown us about investments in AI, right? You had mapped on X and Y axis number of deals that go through and where the money is getting invested. And if I recall correctly, you had spoken about a large chunk of money obviously getting invested in foundation models and obviously number of deals increasing, but in terms of value, the amount of money getting invested in foundation models is, obviously the highest because obviously it's solving the largest problem in terms of the democratization of Gen AI. Um, However, what I want to know is, given the fact that today you've actually mapped it out for us, through that infra map and the consumer map, how do we think about it as business leaders? And I'll ask a slightly more specific question. How do we think about it as business leaders in terms of where the value is getting created for us as business leaders? Because I'm conscious of the fact that, the 25 people sitting here on this call today, unless we're already working for OpenAI or Anthropic, etc., are not in the business of building foundation models because that's going to
Yes.
cost hundreds of millions of dollars and billions of dollars. We're all, leaders in our own organizations and are all going to bring these innovations to our organizations. And should AI? I shouldn't say should AI become an important part. It's going to become it's going to transform all our businesses in the next 12 to 36 months. And as we start building our own stack, implementing our own stack, the next question will arise is how do we monetize this stack, right?
Yes.
How as business leaders, how do we think about the value creation moment where does the value sit essentially? What is the framework for our assessment of value creation? I'm sorry if this is a very generic question.
Yeah. So I may not be able to address all of them in this one. I understand where you are coming from. So we are going step by step. So yes, your connection to the previously what the number of deals and then connection to our earlier generic infrastructure stack with infrastructure doesn't mean that everything is infrastructure only, but it started from infrastructure and this is where the different compartments what I'm talking about till the observability. Then
Right.
similarly, the market thing is there. So that gives you a bigger perspective in terms of how the people are trying to use, where the people are trying to use. Then what I recommend you to create that value creation. That's the real crux of the problem, right? So what we are doing all the building blocks in the last few sessions or even going forward another 10 sessions also what we do is understand the depth of these in terms of what is relevant. It's not like we don't want to go too deep into that, but at the same time, understand the level of depth for a business leader. And then in this process, when you understand, okay, foundational models are there, what you are trying to choose the foundational model is what we have talked so far. Then tomorrow I'm talking about prompt engineering, then again context engineering, then again RAG, because these are all the things which are connected together to bring the value. It's not like, okay, I'll give you a foundation model, I'll choose some kind of these 4, 5 things, and your job is done. No, it is just a starting point. You decided you want to go with a local thing or maybe some kind of a model based on these things. It's not like a randomly you are picking. On top of it, whether it is prompt engineering is good enough to get your answer, do we need to go with the RAG or you need to go with the combination, what kind of design pattern, these are all again, it lies within the purview of you to create at the end the value, right? So in general, Gen AI, we call it as CLP as we talked in the first session, the cost, performance, and latency. So the value creation is a trade-off of these. Sometimes I may get good latency, good performance at the cost of maybe double the cost of what you are expecting. No, I don't want to cross that. You tell me what you are trying to optimize it for. So those kind of trade-offs is very much possible. And I'm sure you will be able to get to those things while we are progressing. We are still in the beginning step.
Got it. Appreciate it. If you don't mind, I'll ask this question again, and maybe we can throw it over
Yeah,
to
no
Mr.
problem.
Nitin.
Just go through that, the same question we are asking, and then maybe in every session we are able to get some part of the answer because there is a bigger question, right? So whatever we are, let's have a checkpoint after 4, 5 sessions, then where are we on this? So at least as of now, you understand how you want to choose the model for your application. That much. On top of it, it is not giving you directly the answer. You need to do the fine tuning, or whether you need to go with the prompt engineering, context engineering, then you are going with some kind of mm, the what you call the parameter efficient fine tuning, whatever is suitable. So then we will be able to get the final value of that.
Got it. Thank you, Prof.
Okay. So
Professor?
yeah,
So
go
I
ahead.
finally remember the question. So in the market, they say something like data single source of truth, and then AIOS, and then second brand. So all of these somehow, from what I understand, is the same thing they're talking about. Is the management of data, and what we learning like all of those like layers are how you will structure or manage your data within the data, within your organization, and how you're going to use it to make decision and how to optimize it, right? The whole process is like that.
Yeah.
Like using all of those like applications, they so that we can like structure like intelligently the flow of data in our company, right?
True.
It is like building the AIOS in a company.
Yeah, definitely. So you are trying to understand all these building blocks. By end of that particular module, you should be equipped enough or confident enough to choose the right components, right building blocks for your enterprise. So while I am telling you the general information with the experience from practical aspects, it is your duty how do you map it to your own scenario, whether it's a startup scenario, whether it's an enterprise AI scenario, and how you want to bring it. And that's where the real value comes at the end of the module.
Yes, because I always have heard that whatever you do, you need to have your data clean first, like in one thing first.
Definitely.
And it has to be like in structure, and then from there you use it in any areas of your companies, area of the business.
Agreed.
Thank you.
Agreed. So I think more or less we are there. And then what I will do now before I go to the this deck anyway, I'll share immediately after the session. So I do have a couple of references. Then tomorrow is 12th July, right? Yeah. So we will concentrate on prompt engineering. Till now, in the last 3 sessions, we talked about the foundations of these Gen AI, then foundational models we talked about, why it is important, what kind of hardware engineering we talk about for that. Then once you are able to get that and we agreed on what to choose or how to choose based on what parameters, then we go into the prompt engineering and then try to cover the parameters, designing the prompts, what kind of simple prompts, zero shot, few shot, or even the chain of thought. So some of those aspects. And hopefully, if you are able to done that, parameter efficient fine tuning also, we will be able to cover. So that's the target for this. And then if you want to brush some of these aspects, these are the things which we are trying to cover there. Okay. So once you are good so far, then last 10 minutes I'll take for let me share the assignment. I'll give you the glimpse of that. Okay. Assignment 1. All right. Yeah. Both assignments, I told you in terms of the gist, why we are testing like that, right? So let me open both of them and then share that screen for you. Just 10 minutes. And after that, I'll leave it open for you to leave. I can share the entire screen, no problem, so that it will be flexible for me. Yeah, so this is what the assignment. I don't know, I need to close this. Yeah, you can see my screen.
Yes.
Yeah. So this is the same, maybe in a whatever format, whether you get it in the Word format or HTML format or maybe the PDF. So this is the kind of content you will get. So here my aim is not to read line by line. That anyway you can go through that and then ask any specific questions by tomorrow. I'll make sure you will get it before the session, and we can ask any of your questions tomorrow as well. But the main point is, we are talking about like 60% weightage for the assignment 1 and 40 for the group assignment. The first one is using these generative AI pre-trained models. If you want to pick any small problem, I have given you some references. Doesn't mean that you need to take it from there only. Okay, I'm repeating again. I'm not forcing you to choose only from these. Sorry, where are we? Yeah. So I'm not asking you to choose only from these, but these are some problem statement. If you are not clear where to start, you may have so many ideas, or you may have uh, you may not have any of them where to start. These are like reference points. But if you have your own problem statement which you want to follow the same instructions, I'm perfectly fine with that, right? So then when you go to this, what are the things which we will go? This is the kind of thing, right? So where for these jobs, what is the knowledge base you are trying to create? Whether you are taking the some from open source or some which is available in public, or you are creating, you tell that. What is the purpose of it in terms of how are you using what kind of prompt engineering rack? So those that much of knowledge, first 5 sessions of your knowledge will be good enough. But we are sharing upfront even by today, so that you will be starting with the knowledge base. By tomorrow itself, you have good knowledge of the prompt engineering. By next week, one session, you have, I think on 19th you have a lab, and then I think you have on 26th also another lab. So by that time you will get complete control, but you don't require to wait till the last point, right? So my recommendation is you start doing it in terms of the problem statement and then what you are understanding from prompt engineering. Slowly you can build on that, right? Then on top of it, for each of the legal examples of this 10, I do have sample queries and knowledge bases. You can take that as a reference. Then I'm asking you, based on the present scheme of things, can Gen AI help you with fully or partially? You try to justify that. And then I have given clear metrics in terms of these points, where whether you are using prompt engineering only or RAG, you need to justify, or you are trying to go to the PEFT based on the problem statement. I'm okay. So I'm not forcing you. You need to do all the things, right? But whatever you are trying to justify, it should be reasonable for us. Yes, this is a kind of a good approach. Then comes you are trying to talk about. So here you are trying to solve a specific problem. On top of it, what you are talking is I don't want a 50-page, 100-page document. I just limiting to 10-page document where 7 pages is the primarily your knowledge base, description, what are the things which in the rubrics you are trying to follow, just highlight those, including your GenAI solution, okay, architecture diagrams. That also will have some references in our regular sessions. On top of it, you want to have those 3 pages to have some screenshots, right? So that whether you use the Azure as a platform, or Rolama local, or some other platform, we are perfectly fine, okay? But you should be able to produce at the end of the assignment, individual assignment of 10 pages of any problem you have chosen or one of those 10 problems. And it needs to be either the Azure platform what we have given to you or independent of that as well. I am perfectly fine. So just go through these in terms of the 20% each, the weightage, how detailed your knowledge base and then sample queries are. What is the overall solution design? Then how the prompts and RAG is helping you to solve this problem. How are you identifying the solution limitation? Because every solution may not be perfect. Am I enabling you to identify those? And the last one is efforts to make the solution. It's not like theoretical. You are saying, okay, you might have done some work and then you are trying to take the screenshot. That's perfectly fine. So you are trying to give, okay, how you will get this out of 5, good, average, and all. I have given this detailed way. You should be able to answer that. And understand the essence of it is you are picking a problem and able to solve end to end is the criteria for assignment 1. Before I jump to the assignment 2, any questions? I think I'm seeing already one question. Andy.
Yes, I want to ask about because I'm in education sector, so I can choose the
problem statement from there.
No
problem.
Secondary school teacher, no problem.
No
Or
problem.
I am a principal, so I choose the problem in my school.
No problem.
Right. Okay.
It can be one of these, or even if you're within the secondary school teacher or education thing, whatever the example I'm giving is not suitable, you want to pick another one, perfectly fine. These are only for references. If somebody don't have any clue where to start with, please pick it from here. Otherwise, my recommendation is you can have your own problem based on what you are working on and take that as opportunity to show a demonstration of end-to-end working. Working in the sense, at least the screenshots of it. Some people will give the links of that working model also, perfectly fine.
Thank you very much.
This is Professor, this is a descriptive assignment or it is a coding assignment?
No, it's not a coding assignment because this is for the business school people, right? So some people add that, okay, I'm implemented. Anyway, we have 3 pages for implementation. Some of them will give the screenshot of the these what you call the code level also. I'm perfectly fine. Some people are implementing in Python. I'm fine. I'm independent of the problem statement. I'm independent of the tool or platform what you use. Only thing is you need to clearly describe this is what my flow is. This is what it is. And then some people are giving the link, drive link, or maybe some kind of a demo link also. That's perfectly fine.
So which means based on this approach, we should have implemented something.
It can be no code, low code as well. It need not be coding level, right? Because Azure and all will be equipped anyway, prompt engineering, this and all with minimum code or no code, low code. That kind of this is kind of an implementation level assignment. Only thing is not by coding only, right? It can be Azure setup or some low code is fine for me. But something your hands may be becoming dirty by trying that. Okay.
Let's suppose if I solve problem by creating an API and taking LLM endpoint or the data into that and then getting the results out, and that kind of solution is that as well, right?
I didn't get fully your question. Your voice was breaking.
If I'm an API, for example.
Come again? API for what?
For example, if I'm solving this a problem statement from finance domain, right?
Okay.
Yes, I'm into finance, so I have a bit of understanding of that. So maybe I can take that use case, one of those use case, and apply what is the demand of this assignments to some coding
Yes.
where I'm utilizing some APIs or uh, the LLM models which are already there, and then so is that the demand of this assignment, or is it like um, I'm giving a prompt, getting a results, and then then utilizing it into my solution? What
Prompting
is
is
it?
also part of the solution, but that's not the only thing. I want you to understand the problem, design the end-to-end solution architecture. Within that, prompting is also a basic thing which you are taking it part of it. It's not like you are just prompting it somewhere and then just producing it, right? You need to get
Yeah,
the end-to-end picture, right? From you can use prompting and solve it. I'm not saying that is not enough. But only thing is the problem good enough with what you have defined in your architecture only to use prompts, or you need to go a little further in terms of RAG or PFT? You need to decide based on the complexity.
perfect. Got it.
Okay, yeah, one more question, better.
Yeah.
So other
Yes.
people also, my recommendation is you will get it. Once you get it, make sure you go through it and then ask further questions when I'm available tomorrow. Yeah, go
Yeah,
ahead.
thank you. Yeah, just one thing about the 100% or fully answering and the
Okay.
80%. Shall we explain more about what?
Yeah. What
Yeah.
does that mean is, in every case, if based on the use case what you have taken, it doesn't mean that entire flow is becoming automated with Gen AI, right? So you may be realistically telling maybe 40% of my task is getting fulfilled with this because of this reason. You need to give a justification. So if you give hardly anything, then I will ask you why you have chosen that problem if it is not even 20%, right?
Yeah.
I want you to think through that, where you might have started with one problem, then you are not convinced it is not even getting into 20%. But even within the 20% also, your value add is there from a business perspective, you can justify. So that's why I kept it open. But you need to think end to end. It's not like, okay, I don't want you to become a prompt engineer per se to get the right query. That is just one part of the story. You need to get the end to end picture, right, from identification of the problem and to solve it.
Yeah. Clear.
Got it?
Thank you.
Yeah.
Thank you.
Then let me tell you the second assignment also, and then open for questions. And if you have just 5 more minutes, then you can drop off. Further questions are there, I'll be happy to answer anyway. But officially, we'll close in 5 minutes.
First one is individual assignment, right?
Sorry?
First one is individual.
Individual assignment with 60% weightage, which you have started publishing by today. Then I think we have given some date of August first week or something. Then the second assignment is before your 14th presentations. You need to be ready. Okay. So then let me tell you the gist of the second assignment. Second assignment is a group assignment where some people are expanding the first problem to a bigger business problem. There you are talking about a small portion of a problem which is solved by a prompt engineering or a RAG kind of a thing. It's not like a bigger business problem. So some people are expanding that into a bigger business problem where it can be your startup idea. Okay, so just as an analogy, or you are struggling in your enterprise a big unit problem. So at that level, if you are talking, then this is not an implementation level of thing, but this is more of how are you thinking to solve a big problem using Gen AI and giving us the architecture, understand the ROI and product roadmap. And then some people are able to give as a bonus some unique points I already talked about towards the end, some unique points of publishing patents or blogs. And some people are giving the demonstration as well, even though it is just an optional one. So if you want to keep that unique aspects, only that 5 points, but rest of them, it is more of uh, AI strategy, I can say, within the Gen AI thing. But it is not just only strategy means only just at a high level, talking at a high level. No, you are going to the level of architecture, design. Only thing is, I'm not forcing you to implement within the time. If some people are implementing it further, perfectly fine. That's a bonus. Okay, so it is just 3-4 lines only what we have talked about. After that, the rubrics. So in nutshell, what I'm trying to help you out in this evaluation is how well you have defined the problem. What is the complexity of the problem you are trying to solve? Then your solution design, very, very important, right? Some people just tell, okay, 2-3 arrow marks, done. No, I'm going to present to you in this process different views which we typically tried. we can use any of them or some new thing, but only thing is it should be detailed enough to demonstrate, yes, I know the building blocks of this Gen AI. So this is how it looks like. Then this is how the product roadmap and then implementability. Then return on investment analysis. I might be doing something for then 1 year, 2 years, right? So that's another aspect. Then quality of the report. Say there are usually the people confuse because this one you are going to present to me on 15th and 16th as a group. Just before that, you will have your last day to submit, and then you will get your live presentations. Others also will be. It's not like a closed room evaluation. Others also will be there. In that, what is important for us to understand is there is no limit for your report, whether you are using PDF or Word and all. I don't put any restriction there. But my recommendation is because you typically get 15-20 minutes for your presentation, maybe 10 slides, okay, 12 slides. This is the kind of general recommendations from my side. So yeah, that's it. Just think of it as an elevator pitch and all that. That's where 10 slides should be good enough. Then unique aspects, you are trying to do an innovation aspects or any of these blocks, or some of the people are talking about, yes, it is ready for the patent. Those things are also important for us to talk. And then the same points, I have given the rubrics, what does that mean, good, satisfactory and all. Yeah, let me take a pause. You should understand clearly the difference between the assignment or an assignment, what we are trying to address in both the things.
The final outcome is a textual report or a
And a
slide.
presentation, not and because presentation you are giving it to me, and then I am offline evaluating the report as well. If you want to combine it in a zip file and upload, or there are multiple ways to submit, but both of them. And some people are, if you are having some prototype as part of this, just give a link within that presentation as well, so that we will not skip.
So can we go through this in detail and then come back to you with questions?
Yeah, definitely. So because why I'm giving it upfront is you have choice to ask me in every session. I'll dedicate some few minutes to this while you are progressing. Also, I'm there with you, right? So I'm just giving you, instead of just dumping you and you read and come back, I'm spending 10-15 minutes to give you the gist of it. Then I have given the description. You just go through that and then ask the questions tomorrow or in any session till this last submission. Even after submission also people ask. So for their learning. So anytime we can do that. I can dedicate some time towards the end. Maybe after towards the end, last 10 minutes, 15 minutes like that, I can keep that buffer. So if other people are not having those questions, they can leave, and then people who have questions, they can listen to.
Yeah, Professor.
Yeah,
Can
sir.
I use this project? It looks like a start to the doctoral dissertation or a doctoral business plan.
You can. Some of the people extended that earlier as well, so I'm fine. So some people continued from their deep learning kind of a thing. Can I change that problem, enhance the problem? Yeah, as long as it is fitting the requirement, worth solving it, go ahead. No issues for me.
Yeah, because I have like a project question for this class, and I'm going to expand upon that. And it looks like you can even step towards the dissertation or the business plan. Thank you.
Yeah, definitely. There are people who have successfully translated like that.
That's exactly my thoughts as well, Sam.
Yeah.
Thank you. Yeah, same here. You build your dissertation as we go along.
Yeah.
Good way to do it.
Yeah,
Good.
great.
So there are some messages here. Yeah. So people who have other appointments, I don't want to burn too much. So you already made me for the last 3 hours. Hope we added some value. So let me take just 20 seconds in what we covered so far. Today we concentrated on LLM engineering aspect, hardware, then talking about the different tech stack aspects, then how we want to choose this open source versus closed source, what parameters, and towards then we talked about the Devin. That's just a glimpse of what we covered so far, and then we discuss the assignments. And tomorrow we'll continue with the prompt engineering.
Professor, last thing before you leave, please.
Yeah, I'm not leaving. I have time. So at least I'm officially closing. So because people may have other appointments, yeah, please. You can ask. Go ahead.
The group formation.
Yeah.
Because last time we received an email and we reply to the email by the groups. I don't know this time how we gonna.
So if the same groups are continuing, I leave it to the program office. I will tell them if you already have formed groups, you don't have any constraints, let them continue, or they will confirm to you. I don't have any problem on that.
Okay, thank you.
Okay,
Thank you.
got it. So any other questions which I need to answer before we drop off?
Thank you very much.
Thank you.
Thank you. Good night.
Good night.